Certified AutoTech Master Automotive Fundamentals and Shop Safety written by Valentin Vishniakoff published by Infinia Publishing. Introduction. Welcome to Automotive Fundamentals and Shop Safety, the foundational course in your journey towards becoming a skilled and knowledgeable automotive technician. This comprehensive course is designed to equip you with the essential knowledge and skills necessary to navigate the dynamic world of automotive repair safely and effectively. Whether you are a novice with a passion for cars or an individual seeking to enhance your existing mechanical aptitude, this course will provide you with a solid understanding of the fundamental principles that underpin this vital industry. The automotive industry is constantly evolving. It requires a strong foundation in the basics. This course will provide that foundation. The automotive repair field is a complex and ever-changing landscape. Modern vehicles are intricate machines, composed of thousands of interconnected parts, sophisticated electronic systems, and advanced materials. To effectively diagnose and repair these complex systems requires not only mechanical aptitude but also a commitment to continuous learning and a steadfast dedication to safety. This course will introduce you to a wide range of topics, from the basic principles of shop organization and tool usage to the intricacies of electrical circuits and the importance of accurate documentation. Each lesson is carefully crafted to build upon the previous one, creating a cohesive learning experience that will prepare you for the challenges and rewards of a career in automotive repair. The knowledge you gain here will be invaluable. It will serve you well throughout your career. Safety is paramount. Before we delve into the technical aspects of automotive repair, it is crucial to emphasize the paramount importance of safety. The automotive repair environment presents numerous potential hazards, including heavy machinery, electricity, hazardous chemicals, and tools capable of causing serious injury. Throughout this course, we will stress the importance of adhering to established safety procedures, using proper personal protective equipment, PPE, and maintaining a proactive safety mindset. Safety is not just a set of rules, it's a way of thinking that must be ingrained in every action you take in the shop. It is about protecting yourself and your colleagues. It is the most important aspect of this course. Tools of the trade. A significant portion of this course is dedicated to familiarizing you with the tools and equipment commonly used in the automotive repair industry. From basic hand tools to sophisticated diagnostic equipment, you will learn about the proper use, maintenance, and calibration of these essential tools. Understanding the capabilities and limitations of each tool is crucial for performing accurate repairs and preventing damage to components. Proper tool usage is a hallmark of a skilled technician. It is essential for efficient and effective repairs. It is a skill that will be developed throughout this course. Fundamentals of automotive systems. We will also explore the fundamental principles of operation for various automotive systems. While subsequent courses will delve into these systems in greater detail, this course will provide a high-level overview of the engine, transmission, electrical system, brakes, steering, and suspension systems. Understanding how these systems work together is essential for diagnosing problems and performing effective repairs. This foundational knowledge will be built upon in later courses. It is essential for understanding how vehicles operate. It is the basis for all future learning. The importance of information. In the information age, the ability to access, interpret, and apply technical information is paramount. This course will introduce you to the various sources of automotive repair information, including original equipment manufacturer, OEM, service manuals, online databases, and technical service bulletins, TSBs. You will learn how to navigate these resources, decipher complex wiring diagrams, and understand the importance of adhering to manufacturer specifications. Knowing where to find the right information is crucial. It is just as important as knowing how to use it. It is a skill that will be honed throughout this course. Documentation and communication. Finally, we will touch upon the importance of accurate documentation and professional communication in the automotive repair setting. While this course will only provide a brief overview of these topics, it will highlight the significance of maintaining detailed repair orders, communicating effectively with colleagues, and fostering a positive work environment. These skills are often overlooked. They are just as important as technical skills. They are essential for a successful career. Building a solid foundation, this course, Automotive Fundamentals and Shop Safety, is designed to provide you with a solid foundation upon which to build your automotive repair expertise. By mastering the concepts and skills presented in these lessons, you will be well prepared to tackle more advanced topics in subsequent courses and embark on a rewarding career in the automotive industry. The journey to becoming a skilled automotive technician begins with a single step, and this course represents that crucial first step. Embrace the challenges, commit to learning, and always prioritize safety. This course will provide you with the knowledge and skills you need to succeed. It is the first step on a path to a rewarding career. Welcome to the world of automotive repair. Lesson 1, Introduction to the Automotive Industry, Technician Roles, Responsibilities, and Basic Ethical Standards. The automotive industry is a dynamic and ever-evolving field that plays a crucial role in modern society. Vehicles, from compact cars to heavy-duty trucks, are essential for personal transportation, commerce, and countless other applications. As an aspiring automotive technician, you are embarking on a journey to become a vital part of this industry, responsible for maintaining, repairing, and ensuring the safety of these complex machines. Without capable technicians, the transportation industry would grind to a halt. Technicians are at the forefront of keeping vehicles safe and on the road. The role of an automotive technician is multifaceted and demands a diverse skill set. A technician is not simply someone who changes oil or replaces tires. They are problem solvers, diagnosticians, and skilled craftspeople who possess a deep understanding of mechanical, electrical, and increasingly, computer-based systems. Technicians must be able to accurately diagnose vehicle malfunctions, identify the root cause of problems, and execute repairs efficiently and effectively. Today's technicians must adapt to the ever-changing landscape of the automotive industry. Aspiring professionals should be prepared to study, as the field is constantly changing. To succeed in this field, one must have a genuine passion for automobiles and a strong desire to learn continuously. The rapid advancements in automotive technology require technicians to stay abreast of the latest developments, tools, and repair techniques. This includes everything from new diagnostic equipment to updated repair procedures. Professional development through formal education, online courses, and industry certifications is an integral part of becoming a highly skilled technician. It is imperative that one is willing to adapt to changes as time goes on, as vehicles are not going to get any simpler. Furthermore, the automotive industry is built on a foundation of trust and integrity. Vehicle owners rely on technicians to provide honest assessments, fair pricing, and quality workmanship. Technicians must ensure that the customer's vehicle is repaired correctly, the first time. Ethical conduct is paramount, and technicians are expected to adhere to high professional standards in all aspects of their work. A mechanic that is unethical will not last long in this industry. A good technician should treat every vehicle as if it were their own. A technician's responsibilities extend beyond technical expertise. They must also possess excellent communication skills, both written and verbal. Clearly explaining complex technical issues to customers, documenting repairs accurately, and collaborating effectively with colleagues are essential aspects of the job. Many customers will not understand the technical jargon of the automotive world. Technicians must be willing to learn how to deal with customers in a manner they can understand. Many technicians will find that good communication is the key to building a loyal customer base. Problem solving is a cornerstone of the automotive technician's role. Each vehicle that enters the shop presents a unique set of challenges. Technicians must be able to think critically, analyze symptoms, and develop logical troubleshooting strategies to pinpoint the source of a problem. Often, a customer will describe a symptom that may be caused by a variety of issues. A good technician must be thorough and patient in order to properly diagnose a vehicle. Rushed or improper diagnosis can lead to wasted time and money. The automotive repair landscape encompasses a wide range of specializations. Some technicians choose to focus on specific areas, such as engine performance, transmission repair, or electrical diagnostics, while others prefer to be generalists who can handle a broader spectrum of repairs. A technician may also choose to specialize in certain makes of vehicles. The modern automotive technician is far removed from the stereotypical grease monkey of the past. Today's technicians are highly trained professionals who utilize sophisticated diagnostic equipment and follow detailed repair procedures. With the advent of computerized systems, the role of the technician has changed dramatically. Beyond the technical aspects, the automotive industry is increasingly focused on environmental responsibility. Technicians play a role in ensuring that vehicles meet emission standards and that hazardous materials are handled and disposed of properly. Proper handling ensures a safe shop and a safe planet, as many of these materials can be harmful to the environment if not disposed of properly. Technicians must follow all regulations regarding hazardous waste. Safety is of utmost importance in the automotive repair environment. Technicians work with heavy machinery, high-voltage electrical systems, and potentially hazardous chemicals. Adhering to strict safety protocols and using appropriate personal protective equipment is crucial to prevent accidents and injuries. Proper training is essential to avoiding accidents, and all safety procedures should be followed. A safe shop is a productive shop. The demand for skilled automotive technicians is consistently high. As vehicles become more complex and the number of cars on the road continues to grow, the need for qualified professionals to maintain and repair them will only increase. There will always be a need for well-trained technicians. Those entering the field should be prepared for the changes that occur, and be ready to adapt to new technologies as they emerge. The automotive industry provides ample opportunity. Career paths in the automotive industry are varied and offer opportunities for advancement. Experienced technicians can progress to supervisory roles, become service advisors, or even open their own repair shops. Many find themselves working at dealerships, working on newer vehicles, where they often receive specialized training from the manufacturer. Some technicians may choose to become mobile mechanics, traveling to their customers. The ethical considerations in the automotive field are significant. Technicians are often entrusted with the safety and well-being of their customers. Providing accurate diagnoses, recommending necessary repairs, and avoiding unnecessary work are fundamental ethical obligations. One must avoid the temptation to oversell, as this can damage their reputation and erode customer trust. Ethical behavior is the cornerstone of a successful career in the automotive field. Transparency in pricing and billing is another critical aspect of ethical conduct. Customers should be provided with clear and detailed estimates before any work is performed, and any deviations from the original estimate should be communicated promptly and transparently. A shop that fails to provide clear pricing may struggle, as customers appreciate honesty and upfront pricing. Hidden fees and surprise charges should always be avoided. Maintaining confidentiality is also important. Technicians may have access to personal information about their customers, and this information must be handled with discretion and respect. Customer data should never be shared without their consent. The more one focuses on building trust, the more clients one will gain. A technician's reputation is built on their ethical conduct. The automotive industry is subject to various regulations and standards. Technicians are expected to be aware of and comply with all applicable laws and regulations, including those related to safety, emissions, and hazardous materials. The law is there for a reason, and must be followed. Ignorance of the law is not an excuse. Staying informed about changes in regulations is part of a technician's ongoing professional development. Ethical behavior builds trust with customers, fosters a positive reputation, and contributes to the long-term success of both the individual technician and the repair shop as a whole. This will allow a technician to build a strong customer base, as customers are more likely to return to a shop they trust. Word-of-mouth referrals are often a result of ethical and professional conduct. Continuing education is not just a recommendation in the automotive field, it is a necessity. Manufacturers regularly introduce new models with advanced technologies, and technicians must stay current with these developments to provide effective service. Technicians must also stay up to date with safety regulations, which are updated periodically. Failure to stay current can lead to improper repairs and potential safety hazards. Industry certifications, such as those offered by the National Institute for Automotive Service Excellence, ASE, demonstrate a technician's competence and commitment to professional standards. Obtaining these certifications requires passing rigorous exams and meeting experience requirements. These are a standard for a well-trained individual, and are recognized throughout the industry. Many employers prefer or require ASE certification. Many technical schools and community colleges offer automotive technology programs that provide a solid foundation in the fundamentals of vehicle repair. These programs often combine classroom instruction with hands-on training in a shop environment, providing students with practical experience. A proper education is essential to getting a good job in the automotive field. Many of these programs also offer job placement assistance. Online learning platforms and training resources are also becoming increasingly prevalent, offering technicians flexible and convenient ways to expand their knowledge and skills. These resources can cover specific topics, such as hybrid vehicle technology or advanced diagnostic techniques. These are often provided by the dealer or manufacturer. Online resources can be accessed from anywhere, at any time. Mentorship plays a valuable role in the development of aspiring technicians. Experienced professionals can provide guidance, share their expertise, and help new technicians navigate the challenges of the industry. This can be a formal or informal arrangement, and can be invaluable to a new technician. Learning from someone with years of experience can greatly accelerate a new technician's development. The automotive industry is increasingly globalized, with manufacturers and suppliers operating in multiple countries. This interconnectedness presents both opportunities and challenges for technicians. Technicians may find themselves working on cars from many different countries, each with its own unique design and engineering. This globalization also means that parts may need to be sourced from overseas. Technicians may have the opportunity to work with vehicles and technologies from around the world, broadening their experience and expertise. The market is always changing, and one must be prepared to adapt to new markets and technologies. This exposure to different technologies can make a technician more versatile and valuable. However, this globalization also means that technicians must be aware of different standards and regulations that may apply to vehicles from different regions. Not all standards are the same, depending on country of origin. For example, emission standards may vary significantly between countries. A technician must be knowledgeable about these differences. The rise of electric and hybrid vehicles is transforming the automotive landscape. Technicians will need to acquire new skills and knowledge to work on these vehicles, which have unique powertrains and electrical systems. These vehicles are becoming more prevalent, and represent a significant shift in the industry. Specialized training is often required to work on these complex systems. The increasing use of computer systems in modern vehicles requires technicians to be proficient in software diagnostics and programming. Modern vehicles are essentially rolling computers. This is a far cry from the skills needed decades ago, when vehicles were primarily mechanical. Technicians must be comfortable using computers and diagnostic software. Customer service is an integral part of the automotive technician's role, even though they may not interact with customers as frequently as service advisors. Building good relationships with the service advisors is important, as they are often the primary point of contact for customers. A technician's ability to clearly communicate technical information to the service advisor can greatly improve the customer experience. Technicians should strive to be courteous, respectful, and professional in all their interactions, whether with customers, colleagues, or supervisors. A positive attitude can go a long way in creating a pleasant work environment. People are more likely to work with pleasant people, and a positive attitude can be contagious. This professionalism should extend to all aspects of their work. Effective communication is key to providing excellent customer service. Technicians should be able to explain technical issues in a way that customers can understand, avoiding jargon and technical terms whenever possible. One may find it easy to forget that the customer likely doesn't understand technical terms, so it's important to use plain language. This helps to build trust and rapport with customers. Listening attentively to customer concerns is equally important. Customers may provide valuable information that can help in diagnosing a problem, even if they don't fully understand the technical details. Even if the customer is wrong, they still deserve to be heard, and their concerns should be addressed respectfully. A good listener can often gather clues that aid in diagnosis. Timeliness and efficiency are highly valued in the automotive industry. Customers appreciate technicians who can complete repairs promptly and get their vehicles back to them as soon as possible. Completing a job on time shows respect for the customer and their time. Of course, it's important to balance speed with accuracy and thoroughness. Maintaining a clean and organized workspace is not just about aesthetics, it is also about safety and efficiency. A cluttered shop can be dangerous, increasing the risk of accidents and injuries. Tools and parts can also be easily lost or damaged in a disorganized environment. A well-organized shop allows technicians to work more efficiently, as they can easily find the tools and parts they need. This saves time and reduces frustration, allowing the technician to focus on the task at hand. This also helps prevent loss of tools, which can be costly and time-consuming to replace. Properly storing tools and equipment helps to prevent damage and prolong their lifespan. This is especially important for expensive diagnostic equipment, which can be easily damaged if not handled and stored correctly. This also helps keep the equipment in good working order, ensuring accurate readings and reliable performance. A clean and organized shop also creates a more professional impression on customers. This can instill confidence in the technician's abilities and the quality of the work being performed. A good impression goes a long way in building customer loyalty. Customers are more likely to return to a shop that appears clean and well-maintained. Regularly cleaning the shop floor, workbenches, and equipment helps to prevent accidents and injuries. This is especially important when dealing with fluids that may cause a slipping hazard, such as oil or coolant. Spills should be cleaned up immediately to prevent accidents. Teamwork is essential in a busy automotive repair shop. Technicians often need to collaborate with each other, sharing knowledge and expertise to solve complex problems. Working together efficiently will help the shop run smoother, allowing for more vehicles to be serviced. A team that works well together can accomplish more than the sum of its parts. A positive and supportive work environment can improve morale and job satisfaction. Technicians who feel valued and respected are more likely to be productive and engaged in their work. Positive morale can also improve quality of work, as technicians are more likely to take pride in their work when they feel appreciated. A happy worker is often a productive worker. Open communication among team members is crucial. Technicians should feel comfortable asking for help or sharing information that could be helpful to others. This open communication can prevent errors and accidents, as technicians can learn from each other's experiences. A free flow of information is essential in a complex environment. Respecting the skills and contributions of each team member is important. Every technician brings a unique set of strengths to the table. Recognizing this can build trust and camaraderie, fostering a more collaborative and supportive work environment. A team is only as strong as its weakest link. Conflict is inevitable in any workplace, but it is important to address it constructively. Technicians should strive to resolve disagreements professionally and avoid personal attacks. A professional attitude can help a shop run smoothly, minimizing disruptions and maintaining a positive atmosphere. Conflicts should be resolved quickly and fairly. The automotive industry is constantly evolving, and technicians must be prepared to adapt to new technologies and trends. This adaptability is key to staying relevant in a rapidly changing field. Technicians who are unwilling to adapt will quickly find themselves falling behind. One of the most significant trends is the increasing electrification of vehicles. Electric and hybrid vehicles are becoming more common, and technicians will need to be trained to work on them. This training can be obtained through the dealer or online, and often involves specialized certifications. These vehicles require a different set of skills and knowledge. Autonomous driving technology is also on the horizon. While fully self-driving cars are not yet widespread, many vehicles already have advanced driver assistance systems that technicians need to understand. These systems can be complex to work on, requiring specialized diagnostic tools and training. These systems are becoming increasingly sophisticated. The use of telematics and connected car technology is also growing. These systems allow vehicles to communicate with each other and with infrastructure, providing data that can be used for diagnostics and maintenance. A technician will need to understand how to use this data to effectively diagnose and repair vehicles. This data can provide valuable insights into vehicle performance and potential issues. The way that consumers interact with the automotive industry is also changing. Online car buying and mobile service are becoming more popular, and technicians may need to adapt to these new models. This is a major shift from how things used to be done, and requires technicians to be flexible and adaptable. The industry is becoming more customer-centric. While the automotive industry offers many opportunities, it also presents some challenges. The work can be physically demanding, requiring technicians to stand for long periods, lift heavy objects, and work in awkward positions. Staying physically fit can help mitigate this, and proper lifting techniques should always be used. Ergonomic tools and equipment can also help reduce physical strain. The work can also be mentally challenging, requiring technicians to constantly learn new things and solve complex problems. A technician must always be focused on the task at hand, and be able to think critically and analytically. Problem-solving skills are essential for success in this field. Technicians may also face pressure to work quickly and meet deadlines, especially in busy shops. This pressure can lead to stress and burnout if not managed properly. Taking breaks is important to preventing burnout, as is maintaining a good work-life balance. Time management skills are crucial. Compensation in the automotive industry can vary widely depending on experience, location, and employer. Some technicians may feel that they are not adequately compensated for their skills and expertise. This can be discouraging for some, and may lead them to seek employment elsewhere. It's important for technicians to understand their worth and negotiate fair compensation. Despite these challenges, a career in the automotive industry can be rewarding for those who are passionate about cars and enjoy working with their hands. A technician plays an important role in keeping vehicles safe and reliable, contributing to the smooth functioning of society. The satisfaction of solving a complex problem and getting a vehicle back on the road can be immense. For those with a genuine interest in automobiles, a career as a technician can be both fulfilling and financially rewarding. Lesson 2, Basic Shop Organization and Tool Familiarization, Hand Tools, Power Tools, Equipment Maintenance, and Safe Handling. A well-organized shop is the cornerstone of an efficient and safe automotive repair environment. It's not merely about aesthetics, it's about creating a workspace that fosters productivity, minimizes errors, and ensures the well-being of every technician. Imagine trying to find a specific wrench in a cluttered toolbox or tripping over an air hose carelessly left on the floor. These scenarios not only waste valuable time but also create potential hazards. Proper shop organization is essential for any technician, experienced or new. Disorganization can lead to lost time, damaged tools, and even injuries. This lesson delves into the fundamental principles of shop organization, focusing on the proper identification, use, and maintenance of hand tools, power tools, and essential shop equipment. It will explore practical strategies for creating a workspace that promotes efficiency and, most importantly, prioritizes safety. Every tool has its place, and knowing that place is crucial. From the smallest screwdriver to the largest hydraulic press, understanding the purpose and proper handling of each tool is paramount for any aspiring automotive technician. Hand tools are the foundation of any technician's arsenal. They are the extensions of a technician's hands, allowing them to manipulate fasteners, apply leverage, and perform a multitude of tasks with precision. This category encompasses a vast array of tools, each designed for a specific purpose. Wrenches, for instance, come in various types, such as combination, box end, open end, adjustable, and socket wrenches, each suited for different applications. Understanding the nuances of each type is essential for selecting the right tool for the job, preventing damage to fasteners and ensuring efficient work. Ratchets and sockets are commonly used together. Sockets are another staple of a technician's toolkit. They come in various sizes, both metric and SAE, Society of Automotive Engineers, and drive sizes, typically a 1/4 inch, 3/8 inch, 1/2 inch, and 3/4 inch. They can be used to remove many different types of fasteners. Deep well sockets are useful for reaching recessed nuts and bolts. Impact sockets are designed for use with impact wrenches and are made of stronger steel to withstand the higher torque. Using the right socket is essential. Screwdrivers, seemingly simple tools, also exhibit a surprising degree of variety. Flathead, Phillips, Torx, and Positive are just a few examples of the different types of screwdrivers, each designed to engage with a specific type of screw head. Using the incorrect screwdriver can damage the screw head, making it difficult or impossible to remove. A well-stocked toolbox will have a variety of screwdrivers in different sizes and types. A technician should be prepared for anything. Pliers are another indispensable category of hand tools. From needle-nose pliers for gripping small objects in tight spaces to slip-joint pliers for adjusting grip size and cutting pliers for severing wires, each type serves a distinct function. Locking pliers, also known as vice grips, can be clamped onto objects, freeing up the technician's hands. Proper use of pliers can prevent damage to the object being worked on. Pliers are essential for many tasks. Hammers, while seemingly blunt instruments, require a degree of finesse and understanding. Ball-peen hammers, with their rounded heads, are used for shaping metal and driving punches and chisels. Rubber mallets are used for striking objects without damaging them. Dead-blow hammers are filled with shot, which prevents them from bouncing back when striking an object. Choosing the right hammer for the job is crucial to prevent damage. Beyond these basic categories, a well-equipped shop will contain a plethora of specialized hand tools. These can include punches, chisels, scrapers, picks, and measuring tools like calipers and micrometers. Each tool has a specific purpose, and a skilled technician will know how and when to use them. Proper use and care of these tools will ensure they last a long time. Power tools significantly enhance a technician's capabilities, providing increased speed, power, and efficiency. However, with this added power comes a greater responsibility for safe handling and proper maintenance. Power tools can greatly reduce the time it takes to complete a task. They can also reduce the physical strain on the technician. However, they must be used with caution. Air impact wrenches are a staple in most automotive shops. They use compressed air to deliver high torque, making them ideal for removing and installing lug nuts and other large fasteners. Proper lubrication and maintenance of air tools is crucial to their longevity and performance. They should also be used with the correct air pressure, as specified by the manufacturer. Impact wrenches can save valuable time. Air ratchets, smaller cousins of impact wrenches, provide rapid rotation for faster fastener removal and installation in tighter spaces. They are especially useful for repetitive tasks, such as removing multiple bolts on a panel. They can be used with various sockets and extensions. Air ratchets are a valuable asset in any shop. Electric drills, both corded and cordless, are versatile tools used for drilling holes and driving screws. Cordless drills offer greater portability, while corded drills provide more consistent power. Drill bits come in various sizes and types, each designed for drilling into different materials. Using the correct drill bit is important to prevent damage to the bit and the material being drilled. Angle grinders are used for cutting, grinding, and polishing metal. They can be equipped with various wheels and discs, each designed for a specific task. Safety glasses and gloves should always be worn when operating an angle grinder. Angle grinders can be dangerous if not used properly. They should never be used without the proper guard in place. Bench grinders are stationary tools used for sharpening tools, shaping metal, and removing rust or burrs. They typically have two wheels, one coarse and one fine. Eye protection is essential when using a bench grinder. The tool rest should be properly adjusted to provide support for the workpiece. Bench grinders are essential for maintaining tools. Hydraulic equipment plays a vital role in many automotive repair tasks. Hydraulic jacks, for instance, are used to lift vehicles, providing access to the undercarriage. Floor jacks are commonly used in shops, while bottle jacks are more portable. Jack stands should always be used in conjunction with a jack to support the vehicle safely. Never work under a vehicle supported only by a jack. Hydraulic presses are used for pressing bearings, bushings, and other components. They can generate tremendous force, so it is crucial to use them correctly and with caution. Proper training is essential before operating a hydraulic press. They are a valuable tool for many repair jobs, but can be dangerous if misused. Engine hoists, also known as engine cranes, are used to remove and install engines. They are typically mobile and have an adjustable boom. Chains and slings are used to attach the engine to the hoist. Care should be taken to ensure the engine is properly balanced before lifting. Engine hoists make a difficult job much easier and safer. Proper maintenance of all tools and equipment is essential for ensuring their longevity, performance, and safety. Hand tools should be cleaned and inspected regularly for damage. Worn or damaged tools should be replaced. Power tools require more extensive maintenance, including lubrication, cleaning, and replacement of worn parts. Air tools should be oiled daily. Following the manufacturer's maintenance recommendations is crucial. Regular inspection of power cords and air hoses is also important. Damaged cords and hoses should be replaced immediately to prevent electrical shock or air leaks. Proper storage of tools and equipment also contributes to their longevity. Tools should be stored in a clean, dry environment to prevent rust and corrosion. Toolboxes and cabinets should be kept organized. Safe handling practices are paramount when working with any type of tool or equipment. Personal protective equipment, PPE, such as safety glasses, gloves, and hearing protection, should always be worn when appropriate. Safety glasses protect the eyes from flying debris. Gloves protect the hands from sharp edges and chemicals. Hearing protection is essential when working with noisy equipment. Proper lifting techniques should be used when handling heavy objects. Lifting with the legs, not the back, can prevent back injuries. Using a cart or dolly to move heavy items is also recommended. When in doubt, ask for help. Team lifts can be used for extremely heavy objects. Proper lifting can prevent injuries. Before using any tool or piece of equipment, it is important to read and understand the manufacturer's instructions. This includes understanding the tool's limitations and proper operating procedures. Familiarization with the tool's safety features is also crucial. Never operate a tool you are not comfortable with or have not been trained to use. Proper training is essential. Maintaining a clean and organized workspace is also an important part of shop safety. Spills should be cleaned up immediately to prevent slips and falls. Tools and equipment should be put away when not in use. Aisles and walkways should be kept clear of obstructions. Good housekeeping is essential for a safe work environment. Proper lighting is also important. Proper ventilation is crucial when working with solvents, paints, and other chemicals. Exhaust fans and ventilation systems should be used to remove fumes from the work area. Respirators may be necessary when working with certain chemicals. Proper ventilation protects the technician's health. Always follow Safety Data Sheet, SDS, guidelines. Fire safety is another important consideration in an automotive shop. Flammable materials should be stored properly in approved containers. Fire extinguishers should be readily available and inspected regularly. Technicians should be trained in the proper use of fire extinguishers. Smoking should be prohibited in the shop area. Fire safety is everyone's responsibility. Electrical safety is also paramount. Electrical outlets and wiring should be inspected regularly for damage. Ground fault circuit interrupters, GFCIs, should be used in areas where water is present. Electrical equipment should be properly grounded. Technicians should be aware of the location of electrical panels and shut-off switches. Electrical safety prevents shocks and fires. Lockout/tagout procedures should be followed when servicing equipment. This involves disconnecting the power source and locking it out to prevent accidental startup. Tags should be used to identify the equipment being serviced and the technician performing the work. Lockout/tagout procedures prevent serious injuries. Proper training on these procedures is essential. Regular safety meetings should be held to discuss safety issues and reinforce safe work practices. These meetings provide an opportunity to address any concerns and to share information about new safety procedures or equipment. Safety should always be a top priority in any automotive shop. Open communication about safety concerns is encouraged. In conclusion, a well-organized shop and a thorough understanding of tools and equipment are fundamental to a successful and safe career in the automotive industry. This lesson has provided a comprehensive overview of the basic principles of shop organization, tool identification, maintenance, and safe handling practices. By adhering to these principles, aspiring technicians can establish a solid foundation for their future endeavors in this dynamic and rewarding field. The knowledge gained in this lesson will be built upon in subsequent lessons, further developing the skills and expertise necessary to excel as an automotive professional. Remember, a safe and organized shop is a productive shop, and a knowledgeable technician is a valuable asset. Continuous learning and a commitment to safety will ensure a long and successful career in the automotive industry. This knowledge is essential. Lesson 3, Safety Regulations and Personal Protective Equipment, PPE OSHA Guidelines, Hazard Identification, PPE Use, and Emergency Procedures. The automotive repair environment, while offering a rewarding career path, presents a unique set of potential hazards. Working with heavy machinery, electricity, hazardous chemicals, and tools capable of causing serious injury necessitates a steadfast commitment to safety. This lesson delves into the crucial realm of safety regulations and personal protective equipment, PPE, providing a comprehensive understanding of occupational safety and health administration, OSHA, guidelines, hazard identification, proper PPE use, and emergency procedures. Mastery of these concepts is not merely a matter of compliance, it is fundamental to ensuring the well-being of every technician and creating a safe and productive work environment. A safe shop is a productive shop. OSHA plays a pivotal role in establishing and enforcing workplace safety standards across various industries, including the automotive sector. Understanding OSHA guidelines is not just about avoiding penalties, it's about internalizing a safety-conscious mindset that prioritizes the prevention of accidents and injuries. OSHA regulations are designed to protect workers from harm. These regulations cover a wide range of topics, including hazard communication, personal protective equipment, lockout/tagout procedures, fire safety, and electrical safety. It is the responsibility of both employers and employees to be familiar with and adhere to these guidelines. Compliance is key. One of the fundamental aspects of OSHA regulations is hazard identification. This involves systematically assessing the workplace to identify potential sources of harm. In an automotive shop, these hazards can range from obvious risks, such as moving machinery and heavy objects, to less apparent dangers, such as exposure to toxic chemicals or prolonged noise levels. Identifying hazards is the first step in mitigating them. A keen eye is needed to spot potential dangers. Hazard identification requires a proactive approach. Regular inspections of the work area, equipment, and tools are essential. Technicians should be trained to recognize potential hazards and report them to their supervisors. This includes identifying worn or damaged tools, frayed electrical cords, spills, and any other condition that could pose a risk. Communication is crucial in maintaining a safe work environment. Everyone has a role to play. Once hazards have been identified, appropriate measures must be taken to control or eliminate them. This may involve engineering controls, such as installing machine guards or ventilation systems, administrative controls, such as implementing safe work procedures, or the use of personal protective equipment. Often, a combination of these approaches is necessary to effectively manage risks. The goal is to create a safe work environment. Prevention is always better than cure. Personal protective equipment, PPE, serves as a critical last line of defense against workplace hazards. It is designed to protect technicians from injury when engineering and administrative controls are insufficient to eliminate all risks. PPE encompasses a wide range of items, each designed to protect a specific part of the body from a particular hazard. Proper selection, use, and maintenance of PPE are essential for its effectiveness. It is a vital part of a technician's safety gear. Eye protection is paramount in an automotive shop. Safety glasses or goggles should be worn whenever there is a risk of flying debris, chemical splashes, or other eye hazards. This includes tasks such as grinding, drilling, hammering, and working with compressed air. Face shields provide additional protection when working with chemicals or when there is a risk of larger particles striking the face. Protecting one's vision is of utmost importance. Always wear eye protection when required. Hand protection is equally important. Gloves protect the hands from cuts, abrasions, chemicals, and burns. Different types of gloves are designed for different tasks. Leather gloves provide protection from sharp edges and rough surfaces. Chemical-resistant gloves are essential when working with solvents, oils, and other hazardous substances. Heat-resistant gloves are necessary when handling hot objects. Choosing the right glove for the job is crucial. Protect your hands. Hearing protection is often overlooked but is crucial in the noisy environment of an automotive shop. Prolonged exposure to loud noises can cause permanent hearing loss. Earplugs or earmuffs should be worn when working with power tools, air compressors, or other noisy equipment. The level of noise reduction required will depend on the specific task and the noise level of the equipment being used. Protect your hearing. Don't ignore this. Respiratory protection is necessary when working with chemicals that produce harmful fumes or vapors. Respirators filter the air, removing contaminants before they can be inhaled. Different types of respirators are designed for different types of contaminants. It is essential to choose the correct respirator for the specific hazard and to ensure that it fits properly. A proper seal is essential for the respirator to be effective. Protect your lungs. Foot protection is essential to prevent injuries from falling objects or crushing hazards. Steel-toed boots or shoes provide protection from heavy objects that may fall on the feet. They also provide protection from punctures and electrical hazards. Sturdy footwear is a must in an automotive shop. Protect your feet. Choose appropriate footwear. In addition to these basic categories, other types of PPE may be required depending on the specific task. This can include aprons, coveralls, and specialized clothing designed to protect against specific hazards, such as welding sparks or chemical splashes. Head protection, such as hard hats, may be required in areas where there is a risk of falling objects. Always use the proper PPE for the task at hand. Safety first. Proper use of PPE is just as important as having the right equipment. Technicians should be trained on how to properly don and doff each item of PPE. They should also be instructed on how to inspect PPE for damage and how to properly clean and store it. Damaged or worn PPE should be replaced immediately. It will not provide adequate protection. Regularly inspect your PPE. Emergency procedures are another critical aspect of workplace safety. Every technician should be familiar with the shop's emergency procedures, including evacuation routes, assembly points, and the location of emergency equipment, such as fire extinguishers and first aid kits. Knowing what to do in an emergency can save lives. Be prepared for any situation. Practice emergency drills. Fire safety is a vital component of emergency preparedness. Technicians should know the location of fire extinguishers and how to use them. They should also be aware of the different types of fires and the appropriate extinguishing agent for each type. Flammable materials should be stored properly in approved containers. Smoking should be prohibited in the shop area. Prevent fires before they start. Be aware of fire hazards. First aid is another essential element of emergency preparedness. Every shop should have a well-stocked first aid kit, and at least one person on each shift should be trained in basic first aid and CPR. Knowing how to respond to common injuries, such as cuts, burns, and eye injuries, can make a significant difference in the outcome. Prompt and appropriate first aid can prevent further injury. Be prepared to provide assistance. In the event of a serious accident or injury, it is crucial to know how to contact emergency services. The emergency number, e.g., 911, should be clearly posted near every phone. Technicians should also be familiar with the shop's address and the location of the nearest hospital or medical facility. Knowing how to summon help quickly can save valuable time in a critical situation. Be prepared to act quickly. Every second counts. Regular safety training is essential to ensure that all technicians are up to date on the latest safety regulations and procedures. This training should cover topics such as hazard identification, PPE use, emergency procedures, and safe work practices. Refresher training should be provided periodically to reinforce these concepts. Safety training is an ongoing process. Never stop learning. OSHA provides numerous resources to help employers and employees understand and comply with safety regulations. These resources include publications, training materials, and online tools. OSHA also offers on-site consultation services to help employers identify and correct workplace hazards. Taking advantage of these resources can significantly improve workplace safety. Utilize available resources. Knowledge is power. Beyond formal regulations, fostering a culture of safety is paramount. This means creating an environment where safety is a shared value, and every individual feels responsible for their own safety and the safety of their colleagues. Open communication, reporting of near misses, and a commitment to continuous improvement are all essential components of a strong safety culture. Safety is everyone's responsibility. Promote a culture of safety. In conclusion, a thorough understanding of safety regulations and personal protective equipment is indispensable for anyone working in the automotive industry. By adhering to OSHA guidelines, identifying and controlling hazards, properly using PPE, and being prepared for emergencies, technicians can significantly reduce the risk of accidents and injuries. This commitment to safety not only protects individuals but also contributes to a more productive and efficient work environment. Remember, safety is not just a set of rules, it's a mindset that should be ingrained in every aspect of an automotive technician's work. This mindset will not only protect you but will also contribute to a more successful and fulfilling career. The principles discussed in this lesson will be further reinforced and expanded upon in subsequent lessons, providing a comprehensive understanding of safety practices in the automotive field. Make safety a habit. Your life and well-being depend on it. Lesson 4, Proper Vehicle Lifting and Jacking, Lift Types, Jack Stands, Safety Locks, Spotting Techniques, and Preventing Accidents. Lifting a vehicle is a fundamental task in automotive repair, providing access to the undercarriage for a wide range of maintenance and repair procedures. However, it is also a task that carries significant risks if not performed correctly. A vehicle that is improperly lifted or supported can fall, causing serious injury or even death. This lesson delves into the critical aspects of proper vehicle lifting and jacking, covering various lift types, the importance of jack stands and safety locks, correct spotting techniques, and essential measures for preventing accidents. Mastering these techniques is not just about efficiency, it is about ensuring the safety of every technician who works beneath a raised vehicle. Safety must always be the top priority, and a thorough understanding of lifting procedures is paramount. Before any lifting operation begins, it is crucial to assess the vehicle and the surrounding environment. The vehicle should be parked on a level, stable surface. This is often overlooked but is critical for preventing the vehicle from shifting during the lift. Uneven surfaces can cause instability. The parking brake should be engaged, and the wheels that remain on the ground should be chalked to prevent any movement. Chalking involves placing blocks or wedges in front of and behind the wheels to prevent rolling. The area around the vehicle should be clear of obstructions, and any spills should be cleaned up immediately. A clean and organized workspace is essential for safe lifting. Proper preparation is key to preventing accidents. These steps may seem simple but are vital. There are several types of lifts commonly used in automotive repair shops, each with its own advantages and disadvantages. Two-post above-ground lifts are popular due to their versatility and relatively small footprint. They typically have two arms on each side that are positioned under the vehicle's lifting points. These lifts raise the vehicle by the frame or designated lift points, leaving the wheels hanging free. This provides excellent access to the undercarriage for tasks such as exhaust work, suspension repairs, and tire rotations. Two-post lifts are a common sight in many shops due to their versatility and relatively small footprint. They allow for easy access to most areas under the vehicle. Four-post above-ground lifts are another common type. They have 4 posts and 2 runways that support the vehicle's tires. These lifts are often used for wheel alignments and general vehicle storage. They are generally considered more stable than two-post lifts, but they provide less access to the undercarriage. Four-post lifts are a good choice for certain tasks. They are also useful for storing vehicles. The added stability of four-post lifts is beneficial when working with heavier vehicles. They are ideal for long-term storage as well. In-ground lifts are installed in a pit below the floor level. They can be either single-post or multi-post designs. In-ground lifts offer a clean, uncluttered shop floor when not in use, but they can be more expensive to install and maintain. They also require proper drainage and ventilation in the pit area. In-ground lifts are a good choice for shops with limited space. They provide a clean look. These types of lifts are commonly seen in older shops. They are less common in newer facilities due to installation costs. Scissor lifts are another option, using a scissor-like mechanism to raise the vehicle. They can be either surface-mounted or recessed into the floor. Scissor lifts are often used for quick service tasks, such as tire changes and brake jobs. They are relatively compact and easy to use. Scissor lifts are a versatile option for many shops. They offer a good balance of accessibility and space efficiency. The compact design of scissor lifts is beneficial in smaller shops. These lifts are typically very reliable. Portable lifts, such as floor jacks and bottle jacks, are used for temporary lifting in situations where a permanent lift is not available or practical. Floor jacks are commonly used in shops for a variety of tasks. They use a hydraulic system to raise a lifting arm. Bottle jacks are more compact and are often used for roadside assistance or in situations where space is limited. They are typically used for lifting one corner of a vehicle. Portable lifts are useful in a variety of situations. They are essential for mobile mechanics. They are also useful for home mechanics. Regardless of the type of lift used, it is crucial to understand its proper operation and limitations. Always refer to the manufacturer's instructions for specific operating procedures and safety precautions. Never exceed the lift's rated capacity. Overloading a lift can cause it to fail, resulting in serious injury or damage. Proper training is essential before operating any type of lift. Safety is paramount. Each lift has specific operating procedures that must be followed. It's important to understand the limitations of each lift. Jack stands are an essential component of safe vehicle lifting. Never work under a vehicle that is supported only by a jack. Jacks can fail, even high-quality ones. A vehicle falling off a jack can have catastrophic consequences. Jack stands are designed to support the weight of a vehicle safely and securely. They are typically made of steel and have a wide base for stability. Always use jack stands when working under a vehicle. They are your lifeline. Jack stands are a crucial safety measure. They should be used every time a vehicle is lifted. Jack stands come in various sizes and weight capacities. It is important to choose jack stands that are appropriate for the vehicle being lifted. The combined capacity of the jack stands should exceed the weight of the vehicle. Always use jack stands in pairs, and make sure they are placed on a level, stable surface. Proper placement of jack stands is crucial. They should be positioned under designated lift points, which are typically reinforced areas of the frame or body. The vehicle manufacturer's service manual will specify the correct placement. Before lowering a vehicle onto jack stands, it is important to inspect them for damage. Look for cracks, bends, or other signs of wear. Damaged jack stands should never be used. They should be replaced immediately. Regular inspection of jack stands is essential for safety. Don't take chances with damaged equipment. Replace it. Even small cracks can compromise the integrity of a jack stand. It's better to be safe than sorry. Safety locks are another critical safety feature on many lifts. These locks are designed to prevent the lift from accidentally lowering in the event of a hydraulic system failure. Always engage the safety locks before working under a vehicle. Most lifts have multiple safety lock positions, allowing the vehicle to be secured at various heights. Safety locks are a vital safety feature. Never work under a vehicle without them engaged. They are designed to prevent the lift from falling unexpectedly. They provide a mechanical backup to the hydraulic system. Spotting a vehicle on a lift is the process of positioning the vehicle correctly on the lift arms or runways. Proper spotting is crucial for ensuring the vehicle is balanced and stable when lifted. Incorrect spotting can cause the vehicle to shift or fall off the lift. Always refer to the vehicle manufacturer's recommendations for the correct lifting points. These points are typically reinforced areas of the frame or body that are designed to support the weight of the vehicle. Proper spotting is crucial for safety and stability. It's important to take the time to do it correctly. When spotting a vehicle on a two-post lift, it is important to position the lift arms symmetrically under the vehicle's lifting points. The arms should be adjusted so that they contact the lifting points evenly. The vehicle should be centered on the lift, with equal weight distribution on both sides. This ensures that the vehicle is balanced and stable when lifted. Take your time and ensure proper positioning. Double-check everything. It's important to get the vehicle as level as possible on the lift. On a four-post lift, the vehicle should be driven onto the runways so that the tires are centered and the weight is evenly distributed. The parking brake should be engaged, and the wheels should be chocked to prevent any movement. Ensure the vehicle is properly aligned on the runways. This will ensure stability when the vehicle is lifted. It's also important to ensure the vehicle is driven on straight. The runways provide a stable platform for the vehicle. Before lifting a vehicle, it is important to perform a final safety check. Ensure that the lift arms or runways are properly positioned and secured. Verify that the safety locks are engaged. Check that the area around the lift is clear of obstructions. Make sure that all personnel are clear of the lift area before raising the vehicle. A final safety check can prevent accidents. It only takes a few seconds. It's a good habit to develop. This final check should be performed every time a vehicle is lifted. When raising a vehicle, it is important to do so slowly and steadily. Observe the vehicle carefully as it is being lifted, watching for any signs of shifting or instability. If the vehicle appears to be unstable, stop lifting immediately and reassess the situation. It is better to take the time to correct the problem than to risk an accident. Lift the vehicle slowly and carefully. Observe it closely. This allows you to identify any potential problems early on. It's important to be patient and not rush the process. Once the vehicle is raised to the desired height, engage the safety locks. Lower the lift slightly until the weight of the vehicle is resting on the safety locks. This ensures that the vehicle is securely supported and will not fall in the event of a hydraulic system failure. Always lower the vehicle onto the safety locks. This is a crucial safety step. Never skip it. It's a simple step that can prevent serious injury. This is standard procedure for any lift operation. When working under a vehicle, it is important to be aware of your surroundings. Avoid placing any part of your body under the vehicle's tires or other moving parts. Use caution when working near hot exhaust components or sharp edges. Wear appropriate personal protective equipment, PPE, such as safety glasses, gloves, and sturdy footwear. Be aware of your surroundings at all times. Stay focused on the task at hand. It's easy to get distracted, but it's important to remain vigilant. This awareness can prevent accidents. Lowering a vehicle is just as important as raising it. Before lowering a vehicle, ensure that the area beneath the lift is clear of tools, equipment, and personnel. Disengage the safety locks and slowly lower the vehicle to the ground. Observe the vehicle carefully as it is being lowered, watching for any obstructions or potential hazards. Lower the vehicle slowly and carefully. Ensure the area is clear. This helps to prevent damage to the vehicle or injury to personnel. It's important to be just as careful when lowering a vehicle as when raising it. Regular maintenance and inspection of lifting equipment are crucial for ensuring its safe and reliable operation. Lifts and jack stands should be inspected regularly for damage, wear, and proper operation. Any damaged or worn components should be replaced immediately. Hydraulic systems should be checked for leaks and proper fluid levels. Cables and chains should be inspected for fraying or damage. Proper maintenance is essential for safety and longevity. Follow the manufacturer's recommendations. Regular inspections can identify potential problems before they become serious. This is a vital part of any preventative maintenance program. Training is another essential component of safe lifting practices. All personnel who operate lifting equipment should receive proper training on its use and safety procedures. This training should cover topics such as proper spotting techniques, the use of safety locks and jack stands, weight capacity limitations, and emergency procedures. Refresher training should be provided periodically to reinforce these concepts. Proper training is crucial for preventing accidents. Never operate a lift without it. Training should be comprehensive and cover all aspects of lift operation. It should also include hands-on practice. In addition to formal training, it is important to foster a culture of safety in the workplace. This means encouraging open communication about safety concerns, reporting near misses, and continuously striving to improve safety practices. Everyone in the shop should feel responsible for their own safety and the safety of their colleagues. Safety should be a top priority for everyone. Promote a culture of safety. This involves creating an environment where safety is valued and prioritized. It requires a commitment from everyone in the shop. In conclusion, proper vehicle lifting and jacking are essential skills for any automotive technician. By understanding the different types of lifts, the importance of jack stands and safety locks, proper spotting techniques, and essential safety precautions, technicians can significantly reduce the risk of accidents and injuries. Remember, safety is not just a set of rules, it's a mindset that should be ingrained in every aspect of an automotive technician's work. This commitment to safety will not only protect individuals but also contribute to a more productive and efficient work environment. The principles discussed in this lesson will be further reinforced and expanded upon in subsequent lessons, providing a comprehensive understanding of safe practices in the automotive field. Make safety a habit. Your well-being depends on it. This lesson provides a foundation for safe lifting practices that should be followed throughout your career. Lesson 5, Fasteners, Torque and Thread Repair, Types of Fasteners, Torquing Sequences, Thread Repair Methods, Helicoil, Time Cert. Fasteners are the unsung heroes of the automotive world, holding together everything from the smallest components to the most critical structural elements. Understanding the different types of fasteners, their applications, and the importance of proper torque is essential for any aspiring automotive technician. Incorrectly installed or improperly torqued fasteners can lead to component failure, damage, and even safety hazards. This lesson delves into the intricacies of fasteners, exploring various types, proper torquing techniques, the significance of torquing sequences, and methods for repairing damaged threads, including the use of helicoil and time cert systems. This knowledge is fundamental to performing quality repairs and ensuring the longevity and safety of vehicles. Proper fastener installation is crucial, as it directly impacts the structural integrity of various vehicle components. A thorough understanding of fasteners is paramount. The variety of fasteners used in the automotive industry is vast, each designed for a specific purpose and application. Bolts and screws are perhaps the most common, both featuring a threaded shaft and a head designed for turning with a wrench or screwdriver. Bolts are typically used with a nut to clamp parts together, while screws are often used to fasten into a pre-threaded hole or to create their own threads in a material. Bolts and screws come in various sizes, lengths, and thread pitches, each designed for specific load requirements. The head styles also vary, with hex heads, socket heads, and pan heads being common examples. Choosing the right bolt or screw is crucial for ensuring a secure and lasting connection. Proper selection requires considering the materials being joined and the forces acting upon them. The length of a bolt or screw is also important. Nuts are another essential fastener, used in conjunction with bolts to secure components. Like bolts, nuts come in various sizes and types, including hex nuts, lock nuts, and wing nuts. Lock nuts are designed to resist loosening due to vibration, a common occurrence in automotive applications. There are various types of lock nuts, including prevailing torque nuts and nylock nuts, each employing different mechanisms to maintain tightness. Nylock nuts feature a nylon insert that provides friction against the bolt threads. Prevailing torque nuts have a distorted thread that creates friction. Wing nuts are designed to be tightened and loosened by hand, making them suitable for applications requiring frequent adjustments. The proper nut must always be used with the correct bolt to ensure a secure connection. Nut selection is crucial and should be based on the specific application and environmental conditions. It's also important to consider the material of the nut. Washers are often used with bolts and nuts to distribute the clamping force over a wider area, prevent damage to the surface being fastened, and in some cases, provide locking action. Flat washers are the most common type, providing a smooth bearing surface and distributing the load evenly. This prevents the nut or bolt head from digging into the material being fastened. Lock washers, such as split lock washers and toothed lock washers, are designed to prevent loosening due to vibration by biting into the mating surfaces. Split lock washers have a helical shape that acts as a spring, while toothed lock washers have teeth that dig into the material. Specialized washers, such as sealing washers, are used in applications where a fluid-tight seal is required, preventing leaks around the fastener. Washers play an important role in many applications, particularly in high-stress or dynamic environments. Washer selection is important and should consider factors such as material compatibility and the need for locking. The size of the washer should also be appropriate for the fastener. Beyond these common fasteners, the automotive world utilizes a plethora of specialized fasteners. Studs, for instance, are essentially headless bolts with threads on both ends, often used for mounting components like exhaust manifolds or cylinder heads. They provide a strong and reliable connection, particularly in high-temperature applications where thermal expansion and contraction are a concern. Clips and retainers are used to secure trim pieces, wiring harnesses, and other components, providing a quick and easy fastening solution. These fasteners are often designed for specific applications and may be made of plastic or metal. Rivets provide a permanent fastening solution, often used in bodywork and structural applications, creating a strong and tamper-proof joint. Rivets are installed using a special tool that deforms the rivet, creating a secure connection. Each type of fastener has its specific application and installation method, requiring specialized tools and knowledge. Knowing which fastener to use is essential for any technician. Proper selection ensures the integrity and longevity of the assembly. Different materials require different fasteners. Proper torque is a critical aspect of fastener installation. Torque, in simple terms, is a rotational force. In the context of fasteners, it refers to the amount of force applied to tighten a bolt or nut to a specific level. Applying the correct torque is essential for several reasons. Over-tightening can stretch the bolt beyond its yield point, leading to permanent deformation or even breakage. It can also damage the threads in the nut or the component being fastened, leading to stripping. Under-tightening, on the other hand, can result in the fastener loosening over time due to vibration, potentially leading to component failure or safety hazards. Proper torque ensures a secure and reliable connection, preventing both immediate and long-term problems. Torque is crucial for maintaining the integrity of bolted joints. It ensures that the fastener is providing the correct clamping force. Torque wrenches are specialized tools designed to apply a specific amount of torque to a fastener. There are several types of torque wrenches, including click type, beam type, and digital torque wrenches. Click-type torque wrenches are the most common, emitting an audible click when the preset torque value is reached. This provides a clear indication that the desired torque has been applied, preventing over-tightening. Beam-type torque wrenches use a pointer and scale to indicate the applied torque, requiring the user to visually monitor the reading. This type of wrench requires more attention from the user. Digital torque wrenches provide a digital readout of the torque value and often offer advanced features, such as data logging and angle measurement, providing greater precision and control. Some digital wrenches can also measure the angle of rotation. Proper use of a torque wrench is essential for achieving accurate and consistent results. Calibration is key to ensuring the accuracy of the wrench, and it should be performed periodically. Using a torque wrench correctly requires proper technique and an understanding of the tool's operation. The desired torque value should be set on the wrench according to the manufacturer's specifications. These specifications can typically be found in the vehicle's service manual or other technical documentation. The wrench should be held firmly and rotated smoothly until the desired torque is reached. Avoid jerky movements or applying excessive force, as this can lead to inaccurate readings or damage. For click-type wrenches, stop turning immediately when the click is heard, as this indicates the preset torque has been achieved. Proper technique ensures accurate torque application and prevents damage to the fastener or the component. Practice makes perfect, and familiarity with the tool is essential. Using the correct socket size is also important. Torquing sequences are often specified for applications where multiple fasteners are used to secure a component, such as a cylinder head or a wheel. These sequences are designed to ensure even clamping force and prevent warping or distortion of the component. Following the correct torquing sequence is just as important as applying the correct torque value. A common example is the star pattern used for tightening wheel lug nuts. This ensures even distribution of the clamping force, preventing uneven stress and potential loosening. This is also commonly used on circular bolt patterns. Torquing sequences are crucial for many applications, especially those involving gaskets or critical seals. Always follow the specified sequence, as it is designed to ensure proper assembly and prevent damage. Cylinder heads are a prime example of where a specific sequence is required. Thread repair is sometimes necessary when threads in a component become damaged or stripped. This can occur due to over-tightening, cross-threading, or corrosion. Several methods can be used to repair damaged threads, two of the most common being helicoil and timesert systems. These systems involve installing a threaded insert into the damaged hole, restoring the original thread size and providing a strong and durable repair. Thread repair can save expensive components from being replaced, offering a cost-effective solution. Proper technique is essential for successful thread repair, requiring precision and attention to detail. It's important to follow the instructions carefully. Helicoil inserts are helically wound wire inserts that are installed into a specially tapped hole. The installation process involves drilling out the damaged threads, tapping the hole with a special helicoil tap, and then installing the insert using an installation tool. Once installed, the insert provides a new set of threads that are often stronger than the original threads. The insert is designed to be slightly larger than the tapped hole, creating a tight and secure fit. Helicoil inserts are a popular choice for thread repair due to their ease of installation and wide availability. They are relatively easy to install with the proper tools and training. They are available in various sizes and thread pitches. Timesert inserts are solid, threaded inserts that are also installed into a specially prepared hole. The installation process is similar to that of helicoil, involving drilling, tapping, and then installing the insert using a special tool. Timesert inserts are often preferred for applications where a more robust repair is required. They are known for their strength and durability, providing a permanent repair solution. Timesert inserts are a reliable solution for thread repair, particularly in high-stress or critical applications. They are often used in engine repair and other demanding situations. They are designed to withstand high temperatures and pressures. Both helicoil and timesert systems require careful attention to detail during installation. Using the correct size drill bit and tap is crucial for ensuring a proper fit. The insert must be installed to the correct depth and orientation. Following the manufacturer's instructions is essential for a successful repair. Proper installation ensures a long-lasting repair that restores the integrity of the component. Practice and patience are required to master the installation process. These thread repair systems offer a reliable alternative to component replacement. It's important to use the correct tools for installation. Beyond these specific systems, other thread repair methods exist, such as using thread-forming screws or thread-locking compounds. The choice of method depends on the specific application, the extent of the damage, and the materials involved. In some cases, welding and retapping the hole may be necessary, particularly for larger or more severely damaged threads. Choosing the right method is crucial for a successful repair and may require consultation with experienced professionals. Sometimes, replacement is the only option if the damage is too extensive. It's important to assess the damage thoroughly before deciding on a repair method. Proper fastener selection, torquing, and thread repair are essential skills for any automotive technician. These skills require a combination of theoretical knowledge and practical experience. Understanding the different types of fasteners, their applications, and the importance of proper torque is crucial for performing quality repairs and ensuring the safety and reliability of vehicles. Continuous learning and practice are essential for mastering these skills, as the automotive industry is constantly evolving with new technologies and materials. Technicians must stay updated with the latest advancements in fastener technology. They should also be familiar with the latest repair techniques. Furthermore, safety should always be a paramount concern when working with fasteners and torque wrenches. Always wear appropriate personal protective equipment, PPE, such as safety glasses and gloves. When using a torque wrench, ensure that the socket is properly seated on the fastener and that the wrench is held securely. Avoid using excessive force, and be aware of your surroundings to prevent accidents. Safety should always be the top priority, as improper handling can lead to injury. Proper technique minimizes the risk of injury and ensures accurate results. It's also important to use the correct tool for the job. In conclusion, fasteners are fundamental components in automotive applications, and a thorough understanding of their types, proper use, and associated techniques is crucial for any aspiring technician. This lesson has provided a comprehensive overview of various fasteners, the critical importance of torque, the use of torque wrenches, and the significance of torquing sequences. Additionally, common thread repair methods, including helicoil and time-cert systems, have been explored. By mastering these concepts, technicians can ensure the quality, reliability, and safety of their work. The principles learned in this lesson will be built upon in subsequent lessons, further developing the skills necessary to excel in the automotive field. Continued practice, attention to detail, and a commitment to safety will pave the way for a successful career as an automotive professional. The knowledge gained in this lesson is essential for any technician and serves as a foundation for many future repairs. This understanding of fasteners is crucial for success in the field. Lesson 6, Automotive Systems Overview, High-Level View of Engines, Transmissions, Electrical, Brakes, Steering, Suspension. The modern automobile is a marvel of engineering, a complex machine comprised of numerous interconnected systems working in harmony to provide safe and reliable transportation. Each system plays a vital role in the overall operation of the vehicle, and a fundamental understanding of these systems is essential for any aspiring automotive technician. This lesson provides a high-level overview of the major automotive systems, including the engine, transmission, electrical system, brakes, steering, and suspension. While each of these systems warrants in-depth study, this lesson serves as an introductory exploration, laying the groundwork for more detailed examination in subsequent lessons. This overview will provide a basic understanding of how these systems work together. A thorough understanding of these systems is crucial. The engine is often considered the heart of the automobile, responsible for generating the power that propels the vehicle. Most modern vehicles utilize internal combustion engines, which harness the energy released from the combustion of fuel to create mechanical motion. These engines typically operate on a four-stroke cycle: intake, compression, combustion, and exhaust. During the intake stroke, the piston moves downward, drawing a mixture of air and fuel into the cylinder. The compression stroke follows, where the piston moves upward, compressing the air-fuel mixture. In the combustion stroke, the spark plug ignites the compressed mixture, forcing the piston downward. Finally, during the exhaust stroke, the piston moves upward again, expelling the burned gases from the cylinder. This cycle repeats continuously, creating rotational motion that is transferred to the crankshaft. Internal combustion engines are complex machines. They require precise timing and control. Engines come in various configurations, including inline, V-shaped, and horizontally opposed, boxer, designs, each with its own advantages and disadvantages in terms of performance, packaging, and smoothness. Inline engines have cylinders arranged in a straight line, while V engines have two banks of cylinders arranged in a V shape. Boxer engines have horizontally opposed cylinders. The number of cylinders also varies, with 4, 6, and 8-cylinder engines being the most common. Engines can be naturally aspirated, drawing in air at atmospheric pressure, or forced induction, using a turbocharger or supercharger to increase airflow and power output. Turbochargers use exhaust gases to spin a turbine, while superchargers are driven by the engine's crankshaft. The choice of engine configuration depends on various factors, including performance requirements and packaging constraints. Modern engines are highly efficient. The transmission is another crucial component, responsible for transferring power from the engine to the wheels and allowing the vehicle to operate at different speeds and loads. Transmissions use a series of gears to change the ratio between engine speed and wheel speed. Lower gears provide more torque for acceleration, while higher gears allow for efficient cruising at higher speeds. There are two main types of transmissions, manual and automatic. Manual transmissions require the driver to manually select gears using a clutch pedal and a gear shifter. Automatic transmissions, on the other hand, automatically select the appropriate gear based on vehicle speed, engine load, and other factors. Automatic transmissions use a hydraulic system and a complex set of clutches and bands to change gears. Continuously variable transmissions, CVTs, are a type of automatic transmission that uses a belt and pulley system to provide a seamless range of gear ratios. Transmissions are essential for vehicle performance. Automatic transmissions have become increasingly sophisticated in recent years, with many models featuring 6 or more speeds and advanced control systems that optimize performance and fuel efficiency. Dual-clutch transmissions, DCTs, are a type of automated manual transmission that uses 2 clutches to provide rapid gear changes without interrupting power flow. They offer the performance of a manual transmission with the convenience of an automatic. Hybrid vehicles often use specialized transmissions that integrate electric motors and generators to improve fuel efficiency and reduce emissions. These transmissions are often called eCVTs. The transmission is a complex and vital component that requires regular maintenance. Proper fluid levels are critical for smooth operation. The electrical system is the nervous system of the automobile, providing power for starting, lighting, accessories, and increasingly, sophisticated electronic control systems. The core components of the electrical system include the battery, alternator, starter motor, and wiring harness. The battery provides electrical energy to start the engine and power accessories when the engine is off. The alternator generates electricity while the engine is running, recharging the battery and powering the electrical system. The starter motor uses electrical energy from the battery to crank the engine, initiating the combustion process. The wiring harness is a network of wires that distributes electricity throughout the vehicle. Fuses and relays protect the electrical circuits from overloads and short circuits. The electrical system is becoming increasingly complex. Modern vehicles rely heavily on electronics for engine management, safety features, and infotainment systems. Engine control units, ECUs, monitor and control various engine parameters, such as fuel injection, ignition timing, and emissions control. These systems use sensors to gather data and actuators to make adjustments. Body control modules, BCMs, manage various body functions, such as lighting, power windows, and door locks. Anti-lock braking systems, ABS, traction control, and electronic stability control, ESC, enhance vehicle safety by preventing wheel lockup and maintaining stability during emergency maneuvers. These systems rely on sensors and actuators to monitor and control vehicle dynamics. The electrical system is essential for the operation of modern vehicles. The braking system is arguably the most critical safety system in a vehicle, responsible for slowing and stopping the vehicle. Most modern vehicles use hydraulic braking systems, which utilize brake fluid to transmit force from the brake pedal to the brake calipers or wheel cylinders. When the driver presses the brake pedal, the master cylinder pressurizes the brake fluid. This pressure is transmitted through brake lines to the calipers or wheel cylinders. Disc brakes use calipers to squeeze brake pads against a rotor, creating friction that slows the vehicle. Drum brakes use shoes that press against the inside of a drum. Most modern vehicles use disc brakes on the front wheels and either disc or drum brakes on the rear wheels. Brakes are crucial for safety. Anti-lock braking systems, ABS, are now standard on most vehicles, preventing wheel lockup during hard braking. This allows the driver to maintain steering control while braking. ABS modulates brake pressure to each wheel independently, preventing it from locking up. Traction control and electronic stability control, ESC, further enhance vehicle safety by preventing wheel spin and maintaining stability during cornering or evasive maneuvers. These systems use sensors to monitor wheel speed, steering angle, and yaw rate. They can apply brakes to individual wheels or reduce engine power to maintain control. Proper maintenance of the braking system is crucial for safety. Brake pads and rotors should be inspected regularly. The steering system allows the driver to control the direction of the vehicle. Most modern vehicles use rack and pinion steering, which provides precise and responsive steering. The steering wheel is connected to a steering column, which transmits rotational motion to the steering rack. The rack converts this rotational motion into linear motion, moving the tie rods. The tie rods are connected to the steering knuckles, which pivot the front wheels. Power steering systems use hydraulic or electric power to assist the driver in turning the steering wheel, reducing steering effort. Hydraulic power steering uses a pump driven by the engine, while electric power steering uses an electric motor. Steering systems require periodic maintenance. Some vehicles use a recirculating ball steering system, which is commonly found on trucks and older vehicles. This system uses a series of ball bearings to reduce friction and provide smoother steering. Steering systems can also incorporate advanced features, such as variable ratio steering, which adjusts the steering ratio based on vehicle speed. This provides more precise steering at high speeds and easier maneuvering at low speeds. Active steering systems can even adjust the steering angle independently of the driver's input to enhance stability and handling. The steering system is essential for vehicle control. Proper alignment is crucial. The suspension system is responsible for providing a smooth and comfortable ride while maintaining tire contact with the road. It absorbs shocks from bumps and uneven road surfaces, and it helps to keep the vehicle stable during cornering and braking. Suspension systems typically consist of springs, shock absorbers, or dampers, and various linkages. Springs support the weight of the vehicle and absorb shocks. Shock absorbers control the movement of the springs, preventing excessive bouncing. There are several types of suspension systems, including independent suspension, which allows each wheel to move independently of the others, and solid axle suspension, where two wheels are connected by a solid axle. Independent suspension generally provides better ride quality and handling. Suspension systems are crucial for ride comfort and handling. Different types of springs are used in suspension systems, including coil springs, leaf springs, and air springs. Coil springs are the most common type, providing a good balance of ride comfort and handling. Leaf springs are typically used on trucks and heavy-duty vehicles. Air springs use air pressure to support the vehicle and can be adjusted to change ride height and stiffness. Shock absorbers can be either hydraulic or gas-charged. Some vehicles use struts, which combine the spring and shock absorber into a single unit. Active suspension systems use electronic controls and actuators to adjust the suspension in real time, providing optimal ride quality and handling in various driving conditions. These systems can adjust damping and ride height. Lesson 7. Service Manuals and Technical Information. Navigating OEM Guides, Online Databases, Reading Specifications. In the complex world of automotive repair, accurate and reliable information is the cornerstone of successful diagnosis and repair. Guesswork has no place in this field. Technicians must rely on authoritative sources to ensure they are performing procedures correctly, using the right parts, and adhering to manufacturer specifications. This lesson delves into the vital realm of service manuals and technical information, exploring the intricacies of navigating original equipment manufacturer, OEM, guides, utilizing online databases, and interpreting technical specifications. Mastering these resources is not just about finding information, it's about developing a systematic approach to problem solving and ensuring the quality and safety of every repair. The ability to find and understand technical information is crucial for any technician, regardless of their experience level. This information is essential for proper diagnosis, repair, and overall vehicle maintenance. It is the foundation upon which all repairs are built, and it is the key to providing effective and efficient service. Access to the right information is paramount. OEM service manuals are the gold standard for automotive repair information. These comprehensive guides are produced by the vehicle manufacturers themselves and contain detailed procedures, specifications, diagrams, and troubleshooting information specific to each vehicle make and model. They are the definitive source of information for technicians, providing step-by-step instructions for everything from routine maintenance to complex engine overhauls. OEM manuals are typically organized by vehicle system, such as engine, transmission, brakes, electrical, etc., making it relatively easy to find information on a specific component or procedure. They often include detailed illustrations and diagrams to aid in understanding the often complex systems and procedures. These visuals can be invaluable when working on unfamiliar components or systems. These manuals are essential for any technician, whether working in a dealership, independent shop, or on their own vehicles. They contain a wealth of information that is not available anywhere else, representing the manufacturer's accumulated knowledge and expertise. They are the most reliable source of information, ensuring that technicians have access to the most accurate and up-to-date data. Within each section of an OEM manual, you will typically find detailed specifications, such as torque values, fluid capacities, and electrical tolerances. These specifications are crucial for ensuring that repairs are performed correctly and that components are installed to the manufacturer's standards. For example, a torque specification will indicate the precise amount of rotational force to apply to a fastener, preventing over-tightening or under-tightening. Fluid capacities will specify the exact type and amount of fluid needed for a particular system, ensuring proper lubrication and operation. Electrical tolerances will provide acceptable ranges for voltage, resistance, and current, aiding in the diagnosis of electrical problems. The manuals also include diagnostic procedures, often presented as flowcharts or decision trees, to help technicians pinpoint the root cause of a problem. These diagnostic procedures are based on the manufacturer's extensive knowledge of the vehicle's systems and are designed to streamline the troubleshooting process. Wiring diagrams are another essential component of OEM manuals, providing a visual representation of the vehicle's electrical circuits. These diagrams are invaluable for diagnosing electrical issues, showing the connections between various components, including sensors, actuators, and control modules. They use standardized symbols to represent different components, and understanding these symbols is a crucial skill for any technician. OEM manuals also provide information on special tools that may be required for certain procedures. These tools are often designed specifically for a particular vehicle or component and may not be available through general tool suppliers. Using the correct tools is essential for preventing damage to components and ensuring proper repair. Improper tools can lead to frustration, wasted time, and potentially costly mistakes. Special tools are often necessary for precise adjustments or for accessing hard-to-reach areas. OEM manuals may also include information on recalls and technical service bulletins, TSBs. Recalls are issued and a safety defect is discovered, while TSBs are issued by manufacturers to address common problems or provide updated repair procedures. They often contain valuable information that can save time and effort in diagnosis and repair. Staying up to date with recalls and TSBs is important for providing the best possible service to customers and ensuring that vehicles are safe and reliable. This information can often be found on the manufacturer's website as well, or through online databases. In addition to printed manuals, many manufacturers now offer their service information online through subscription-based websites. These online platforms often provide the same content as the printed manuals but with the added benefits of searchability, regular updates, and sometimes interactive features. Online manuals can be accessed from anywhere with an internet connection, making them a convenient option for technicians. They are often updated more frequently than printed manuals, ensuring that technicians have access to the most current information. These platforms often include video tutorials and other training materials to supplement the written procedures. They may also include wiring diagrams that can be zoomed and panned, making it easier to trace circuits and locate specific components. Interactive wiring diagrams are a significant advancement in diagnostic technology. These online resources are becoming increasingly popular and are revolutionizing the way technicians access and utilize information. Online databases, such as those provided by companies like ALLDATA and Mitchell 1, are another valuable resource for automotive technicians. These databases compile service information from various manufacturers, providing a comprehensive library of repair procedures, specifications, and diagrams for a wide range of vehicles. They often include features such as keyword searching, cross-referencing of parts, and access to technical service bulletins. These databases can be a valuable supplement to OEM manuals, offering a wider range of information in a single location. They often contain information that is not readily available elsewhere, such as aftermarket repair procedures or common fixes for known problems. They are constantly being updated with new information, ensuring that technicians have access to the latest data. They can be accessed from computers, tablets, and even smartphones, making them incredibly versatile. They provide technicians with a powerful tool for research and problem solving. These online databases also often include labor time guides, which provide estimates for the amount of time required to perform specific repairs. This information is useful for creating repair orders and providing quotes to customers. Accurate labor times are crucial for fair pricing and efficient shop management. Some databases also include wiring diagrams, component locations, and diagnostic trouble code (DTC) definitions. They may also provide access to forums or other online communities where technicians can share information and ask questions. These forums can be a great resource for troubleshooting difficult problems or learning new techniques. These databases are a valuable resource for any shop, providing a wealth of information at your fingertips. They can help technicians work more efficiently and accurately, ultimately leading to increased customer satisfaction. They are an investment that can pay for itself many times over. They provide access to a vast library of information that would be impossible to compile independently. Effectively navigating and interpreting technical information requires a systematic approach. When faced with a repair, the first step is to identify the specific vehicle make, model, and year. This information is crucial for ensuring that you are accessing the correct service information. The Vehicle Identification Number, VIN, can also be used to identify specific vehicle options and configurations. The VIN is a unique identifier for each vehicle, like a fingerprint. It contains information about the vehicle's manufacturer, model, year, engine, and other details. The VIN is typically located on the dashboard, near the windshield, or on the driver's side door jamb. It can also be found on the vehicle's title and registration. The VIN is essential for looking up parts and service information. It is a critical piece of information. Once the vehicle is identified, the next step is to locate the relevant section in the service manual or online database. This may involve using the table of contents, index, or search function. It is important to read the entire procedure carefully before beginning any work. This will help to ensure that you understand all the steps involved and that you have all the necessary tools and parts. Pay close attention to any warnings or cautions, which are often highlighted in the manual. These warnings and cautions are there for a reason, to prevent damage to the vehicle or injury to the technician. They should never be ignored. It's also a good idea to familiarize yourself with the layout of the manual so that you can quickly find the information you need in the future. Understanding the structure of the manual is key to using it efficiently. Reading and understanding technical specifications is another crucial skill. Torque values, for instance, must be adhered to precisely to prevent damage to fasteners and components. Over-torquing can strip threads or damage parts, while under-torquing can lead to loose connections and potential failures. Using a properly calibrated torque wrench is essential for achieving the correct torque. Fluid capacities and types must be carefully observed to ensure proper system operation. Using the wrong type of fluid can damage components or affect performance, leading to premature wear or system malfunctions. Electrical specifications, such as voltage and resistance values, are critical for diagnosing electrical problems. Understanding these specifications requires familiarity with units of measurement and the ability to interpret technical data. It's important to double-check all specifications before beginning work. Using the wrong specification can lead to problems, including damage to components or incorrect repairs. Having the right tools for measurement is equally important. Wiring diagrams can be particularly challenging to interpret, but they are essential for diagnosing electrical issues. These diagrams use symbols and abbreviations to represent various components and circuits. Learning to decipher these symbols and trace circuits is a vital skill for any automotive technician. Many service manuals include a key or legend that explains the symbols used in the diagrams. This key is essential for understanding the diagrams, as it provides a translation for each symbol. Practice is essential for mastering the interpretation of wiring diagrams. They can be complex and confusing at first. Start with simple circuits and work your way up to more complex ones. There are often courses available to help technicians learn to read wiring diagrams. These courses can be invaluable for developing this essential skill. Technical Service Bulletins, TSBs, are another important source of information. These bulletins are issued by manufacturers to address common problems, provide updated repair procedures, or announce recalls. They often contain valuable information that can save time and effort in diagnosis and repair. It is important to check for any relevant TSBs before beginning work on a vehicle. TSBs can be found in online databases or on the manufacturer's website. They are often organized by vehicle model and system. Reading and understanding TSBs is crucial, as they may contain important updates or revisions to repair procedures. They may also contain information about known defects or common failures, which can help technicians avoid misdiagnosis. They can often provide solutions to recurring problems. In addition to OEM manuals and online databases, other sources of technical information may be available. Independent repair shops often develop their own internal databases of repair information based on their experience. Online forums and communities dedicated to specific vehicle makes and models can also be valuable resources. However, it is important to exercise caution when using information from unofficial sources, as the accuracy and reliability may vary. Always verify information from unofficial sources with a reputable source, such as an OEM manual or a trusted online database. It's best to rely on OEM information whenever possible, as it is the most accurate and up-to-date. When in doubt, consult with a more experienced technician or seek out additional resources. Cross-referencing information from multiple sources can help ensure accuracy. Furthermore, continuous learning is essential in the ever-evolving automotive industry. New technologies and systems are constantly being introduced, requiring technicians to stay up to date with the latest service information and repair procedures. Attending training courses, reading industry publications, and participating in online forums are just a few ways to stay informed. The automotive industry is constantly changing, with new models and technologies being introduced every year. Technicians must adapt to these changes and continue to learn throughout their careers. Lifelong learning is essential for success in this field. It's important to embrace new technologies and be willing to learn new skills. The best technicians are always seeking to expand their knowledge. In conclusion, the ability to access, navigate, and interpret service manuals and technical information is a fundamental skill for any automotive technician. OEM manuals, online databases, and other resources provide a wealth of information that is essential for performing accurate and reliable repairs. By mastering these resources and developing a systematic approach to problem solving, technicians can ensure the quality and safety of their work. This lesson has provided an overview of the various sources of technical information and the importance of understanding specifications and diagrams. The principles discussed in this lesson will be further developed in subsequent lessons, providing a comprehensive understanding of the role of information in automotive repair. The skills learned in this lesson are essential for any technician and will be used on a daily basis throughout their career. They are the foundation upon which a successful career is built. This is a crucial lesson for anyone entering the field. Being able to find and use the right information is a cornerstone of being a good technician. Lesson 8, Shop Tools and Equipment Calibration, Torque Wrenches, Air Gauges, Scan Tools, Alignment Racks, Periodic Calibration. In the precision-driven world of automotive repair, the accuracy of tools and equipment is paramount. A properly calibrated tool is not just a convenience, it is a necessity. Incorrect measurements can lead to faulty repairs, damaged components, and even safety hazards. This lesson delves into the significant area of shop tools and equipment calibration, focusing particularly on torque wrenches, air gauges, scan tools, and alignment racks. We will examine how periodic calibration of these instruments ensures accurate measurements and forms the foundation of professional automotive repair work. A well-maintained tool will provide accurate readings. A properly calibrated tool is a technician's best friend. It allows for confident repairs. Torque wrenches are essential tools for applying the correct torque to fasteners, and their accuracy directly impacts the quality of repairs and the safety of vehicles. A torque wrench's calibration can drift over time, especially with regular use. Therefore, periodic calibration is essential to ensure that the wrench is delivering precise torque settings. The calibration process typically involves comparing the wrench's readings to a certified calibration device. If the wrench is found to be out of calibration, it needs to be adjusted or replaced. Applying the correct torque is of utmost importance. Without calibration, a torque wrench cannot be relied upon. It is a crucial step. Different types of torque wrenches may require different methods for calibration. Click-type torque wrenches, for example, often need to be adjusted at a calibration lab, where specialized equipment is used to test the accuracy of the wrench's clicking mechanism. Beam-type torque wrenches can usually be calibrated by the user, using a known weight and ensuring that the pointer indicates 0 on the scale. Digital torque wrenches often feature a built-in calibration mode that allows the user to calibrate the wrench themselves. It is crucial to follow the manufacturer's instructions for the correct calibration procedure. Improper calibration can further compromise the accuracy of the wrench. Calibration frequency depends on usage. It's important to follow guidelines. Air gauges are another critical tool that requires regular calibration for accurate measurements. These gauges are used to measure tire pressure, air tool systems, and other pneumatic components. Incorrect tire pressure can adversely affect vehicle handling, fuel efficiency, and tire life. Therefore, maintaining the accuracy of air gauges is of great importance. The calibration process typically involves comparing the gauge's readings to a certified master gauge. If any discrepancies are found, the gauge needs to be adjusted or replaced. Regular calibration of air gauges is essential. Incorrect tire pressure can be dangerous. It can also lead to premature tire wear. Most air gauges are relatively simple devices, but their calibration may still require specialized equipment. A common method is to use a known good tire and measure its pressure with a certified master gauge. Then, the gauge being tested is used to measure the tire's pressure, and the readings are compared. If the readings differ significantly, the gauge is out of calibration and needs adjustment or replacement. It is important to regularly monitor tire pressure. Correct inflation extends tire life. It also improves fuel economy. Scan tools have become indispensable tools in modern automotive diagnostics. These electronic devices interface with a vehicle's onboard computer systems, allowing technicians to retrieve diagnostic trouble codes, DTCs, view live data streams, and perform various tests. The accuracy of scan tools is crucial for accurate diagnosis and effective repairs. While scan tools themselves are not calibrated, their software and firmware may require periodic updates to ensure they remain compatible with the latest vehicle models and systems. An outdated scan tool may not read all codes. Software updates are extremely important. They ensure compatibility. Scan tool manufacturers often release software updates that add support for new vehicles, improve compatibility with existing protocols, and fix software bugs. These updates can usually be downloaded from the manufacturer's website or through dedicated software. The specific process for updating a scan tool varies depending on the model but typically involves connecting the device to a computer and running the update software. Regularly checking for and installing software updates is important to keep the scan tool functioning optimally. An up-to-date scan tool is a valuable asset for a technician. It can communicate with the latest vehicles. It's a worthwhile investment. Alignment racks are another critical piece of equipment that requires periodic calibration to ensure accurate measurements and proper vehicle alignment. Incorrect alignment can result in uneven tire wear, poor handling, and reduced fuel efficiency. Therefore, maintaining the accuracy of alignment racks is of great importance. The calibration process typically involves aligning the rack sensors and measuring devices with known standards. This ensures that the rack is providing accurate alignment readings. Alignment racks are designed for precision. They must be calibrated regularly to maintain that precision. Most alignment racks use highly sensitive electronic components that can drift over time. Therefore, regular calibration of these racks is essential to ensure they are providing accurate measurements. The frequency of calibration depends on usage and should be done according to the manufacturer's recommendations. Many modern alignment racks have self-calibration features that automate the process. However, periodic manual calibration is still recommended to ensure optimal accuracy. A properly calibrated alignment rack is the key to accurate alignments. It helps prevent uneven tire wear. It ensures proper handling. In addition to periodic calibration, proper handling and maintenance of all tools are also important. This includes keeping tools clean and dry, regularly inspecting them for any signs of damage or wear, and following the manufacturer's maintenance schedule. Proper storage and handling can help extend the life of tools and reduce the need for frequent calibration. Tools will last longer if they are used and maintained correctly. Taking care of tools is essential. It is an investment. Torque wrenches, for example, should be handled with care, avoiding dropping them or using cheater bars to increase leverage. These types of misuse can damage the internal mechanisms of the wrench and affect its accuracy. After use, torque wrenches should be returned to their lowest setting to relieve stress on the spring and maintain accuracy over the long term. This protects the spring from becoming set. This helps extend the life of the wrench. It's a good habit. Air gauges should be regularly inspected for any signs of damage or wear, such as cracked lenses or loose components. They should be stored in a location where they are not likely to be dropped or stepped on. If a gauge is dropped, its accuracy should be checked before using it again. A damaged gauge can give inaccurate readings. This can lead to potentially dangerous situations. Always handle them with care. Scan tools should be protected from dust, moisture, and extreme temperatures. They should be stored in a protective case when not in use. The scan tool's cables and connectors should be handled carefully to avoid damaging them. When updating the software, it is important to follow the manufacturer's instructions carefully to ensure that the device continues to function properly. Scan tools should be handled with care. They are expensive electronic devices. Protecting them is essential. Alignment racks should be kept clean and free of debris. The sensors and other sensitive components should be protected from damage. Any moving parts should be lubricated according to the manufacturer's recommendations. Always read and understand the manufacturer's operating instructions before using an alignment rack. Alignment racks should be maintained properly to ensure longevity. They are a major investment for any repair shop. Proper maintenance is key. Ultimately, periodic calibration and proper maintenance of all shop tools and equipment are essential not only for the quality of repairs but also for the safety of technicians. An incorrectly calibrated tool can lead to incorrect repairs, potentially causing damage to vehicles or worse, injuries. A well-maintained tool not only performs more accurately but also lasts longer, saving money in the long run. Proper care of tools is a hallmark of a good technician. It is a sign of professionalism. It shows pride in one's work. The principles discussed in this lesson are applicable to all automotive repair shops, from small independent shops to large dealerships. Attention to the accuracy of tools and equipment should be an integral part of every technician's routine. It is a habit that can only be developed, and the importance of calibration and proper tool handling best practices are thoroughly understood. This knowledge will form the foundation for all future repair work. It enables technicians to work with confidence. It ensures accuracy and safety. In subsequent lessons, we will expand upon these ideas, exploring other crucial aspects of automotive repair. Remember, becoming a skilled and safe technician requires continuous learning and a commitment to adhering to best practices. The lessons learned in this lesson will stay with you throughout your career. They are the core principles of being a successful technician. Subsequent lessons will build upon this knowledge. They will expand on these ideas. Lesson 9, Lubricants and Fluids, Oil Grades, Coolant, Brake Fluid, ATF, Differential Oil, and Correct Usage. Lubricants and fluids are the lifeblood of any vehicle, performing a multitude of vital functions that ensure smooth operation, prevent wear and tear, and ultimately contribute to the longevity and reliability of the automobile. From engine oil to brake fluid, each lubricant and fluid is specifically formulated to meet the demands of its application. Understanding the different types of lubricants and fluids, their properties, and their correct usage is essential for any aspiring automotive technician. This lesson delves into the world of automotive lubricants and fluids, exploring various types, including oil grades, coolant, brake fluid, automatic transmission fluid, ATF, and differential oil, highlighting their specific roles and proper application. Proper maintenance of these fluids is crucial. Using the correct fluid is paramount. Engine oil is arguably the most important fluid in a vehicle, providing lubrication to the engine's internal components, reducing friction and wear. Engine oil also helps to cool the engine, clean internal components by suspending contaminants, and in some cases, seal piston rings. Choosing the correct oil grade is crucial for ensuring proper engine performance and protection. Oil grades are designated by a standardized system developed by the Society of Automotive Engineers, SAE. The designation typically consists of two numbers separated by a W, such as 5W30. The first number represents the oil's viscosity at low temperatures, the W stands for winter. A lower number indicates that the oil flows more easily at low temperatures, which is important for cold starting. The second number represents the oil's viscosity at operating temperature, 100 degrees Celsius or 212 degrees Fahrenheit. A higher number indicates a thicker oil, which provides better protection at high temperatures. The correct oil grade is crucial. It is specified by the manufacturer. Viscosity is a measure of a fluid's resistance to flow. In the context of engine oil, it refers to the oil's thickness. A high-viscosity oil is thicker and provides a greater film strength between moving parts, but it can also increase resistance and reduce fuel efficiency. A low-viscosity oil flows more easily, reducing friction and improving fuel economy, but it may not provide adequate protection under high-load conditions. The choice of oil viscosity depends on various factors, including the engine design, operating temperature, and the manufacturer's recommendations. Using the wrong viscosity oil can lead to premature engine wear. It can also affect performance. Engine oils are also classified by their performance level, indicated by API, American Petroleum Institute, and ILSAC, International Lubricant Standardization and Approval Committee, ratings. These ratings specify the oil's ability to meet certain performance standards, such as oxidation resistance, wear protection, and sludge control. API ratings are designated by two letters, such as SN or CJ4. The first letter indicates the type of engine the oil is designed for, S for gasoline, C for diesel. The second letter indicates the performance level, with higher letters representing more recent and stringent standards. ILSAC ratings are typically used for gasoline engines and are designated by GF followed by a number, such as GF5. These ratings focus on fuel economy and emissions. Using the correct performance level oil is important. In addition to viscosity and performance ratings, engine oils can be either conventional, synthetic, or a blend of the two. Conventional oils are derived from crude oil and are generally less expensive. Synthetic oils are chemically engineered to provide superior performance characteristics, such as improved high-temperature stability, better cold flow properties, and extended drain intervals. Synthetic blends offer a compromise between the performance of synthetic oils and the cost of conventional oils. The choice between conventional, synthetic, or blended oil depends on various factors, including the vehicle's age, mileage, operating conditions, and the manufacturer's recommendations. Synthetic oils often offer better protection. They can also last longer. Coolant, also known as antifreeze, is another vital fluid that plays a crucial role in regulating engine temperature. It circulates through the engine and radiator, absorbing heat from the engine and dissipating it through the radiator. Coolant is typically a mixture of water and ethylene glycol or propylene glycol, which lowers the freezing point and raises the boiling point of the water, preventing the coolant from freezing in cold weather or boiling over in hot weather. Coolant also contains additives that prevent corrosion and scale buildup within the cooling system. Using the correct coolant is important. It prevents overheating and freezing. Different types of coolant are available, each formulated for specific engine types and materials. Traditional green coolant, also known as inorganic additive technology, IAT, is typically used in older vehicles with copper or brass radiators. Organic acid technology, OAT, coolants, often orange or red, are designed for use in newer vehicles with aluminum radiators and components. Hybrid organic acid technology, HOAT, coolants, typically yellow or orange, combine the benefits of IAT and OAT coolants and are compatible with a wider range of vehicles. Using the wrong type of coolant can lead to corrosion and damage to the cooling system. It's crucial to consult the vehicle's owner's manual. Brake fluid is a hydraulic fluid that transmits force from the brake pedal to the brake calipers or wheel cylinders, enabling the vehicle to stop. Brake fluid must have a high boiling point to withstand the heat generated during braking, and it must also resist absorbing moisture, which can lower the boiling point and lead to brake fade or failure. Brake fluid is classified by its Department of Transportation, DOT, rating, such as DOT3, DOT4, or DOT5. 1. Higher DOT ratings generally indicate higher boiling points. DOT5 brake fluid is silicone-based and is not compatible with other types of brake fluid. Using the correct type of brake fluid is essential for safety. Brake fluid should be changed periodically. Brake fluid is hygroscopic, meaning it absorbs moisture from the air. Over time, this moisture contamination can lower the boiling point of the fluid, reducing its effectiveness and potentially leading to brake failure. Therefore, it is crucial to use the correct type of brake fluid specified by the vehicle manufacturer and to replace it at the recommended intervals. Brake fluid should also be checked regularly for its moisture content using a brake fluid tester. Contaminated brake fluid can be dangerous. It can cause the brakes to fail. Automatic transmission fluid, ATF, is a specialized fluid used in automatic transmissions to lubricate moving parts, provide hydraulic pressure for shifting gears, and cool the transmission. ATF has a complex formulation that includes friction modifiers, detergents, and anti-wear agents. Different types of ATF are available, each designed for specific transmission types and requirements. Using the wrong type of ATF can lead to transmission damage, slippage, or premature failure. It is crucial to consult the vehicle's owner's manual or service information to determine the correct ATF for the specific transmission. ATF is vital for proper transmission operation. It should be checked regularly. ATF also plays a role in cooling the transmission. As the transmission operates, it generates heat, and the ATF helps to dissipate this heat, preventing the transmission from overheating. Many vehicles have a transmission cooler, which is a small radiator that helps to cool the ATF. Regularly checking the ATF level and condition is important for maintaining the health of the transmission. ATF should be changed at the recommended intervals, as it can degrade over time due to heat and wear. Dirty or burnt ATF can cause problems. It can lead to transmission failure. Differential oil is a lubricant used in the differential, a component that allows the wheels to rotate at different speeds during turns. Differential oil lubricates the gears and bearings within the differential, reducing friction and wear. It also helps to cool the differential. Different types of differentials, such as open, limited slip, and locking differentials, may require different types of oil. Using the correct type of differential oil is crucial for proper operation and preventing damage to the differential. The owner's manual will specify the correct type. Differential oil should be changed periodically. Differential oil, like other automotive fluids, can degrade over time due to heat and contamination. Regularly checking the differential oil level and condition is important for maintaining the health of the differential. The oil should be changed at the recommended intervals, or more frequently if the vehicle is used in severe conditions, such as towing or off-roading. Proper lubrication is essential for the differential. It ensures smooth operation and prevents wear. Neglecting differential oil changes can lead to costly repairs. In addition to these primary lubricants and fluids, other specialized fluids are used in various automotive systems. Power steering fluid, for example, provides hydraulic assistance for the steering system. Power steering fluid should be checked regularly and replaced according to the manufacturer's recommendations. Using the correct type of power steering fluid is important for proper operation of the steering system. Contaminated or low fluid can cause steering problems. Proper handling and disposal of automotive fluids are also important considerations. Used oil, coolant, and other fluids should be disposed of properly at designated recycling facilities. These fluids can be harmful to the environment if not disposed of correctly. Many automotive repair shops and parts stores offer fluid recycling services. It is important to follow all local regulations regarding the disposal of hazardous waste. Proper disposal protects the environment. It is also the responsible thing to do. In conclusion, lubricants and fluids are essential for the proper operation and longevity of vehicles. Understanding the different types of fluids, their properties, and their correct usage is a fundamental aspect of automotive maintenance and repair. By diligently following manufacturer recommendations regarding fluid types, grades, and service intervals, technicians can ensure that vehicles operate at peak performance and that their vital systems are adequately protected. This lesson has provided a comprehensive overview of the major automotive fluids and their functions. The knowledge gained in this lesson will be built upon in subsequent lessons, providing a deeper understanding of the role of fluids in various vehicle systems. Proper fluid maintenance is crucial for vehicle reliability. It is a key aspect of preventative maintenance. This lesson is crucial for all aspiring technicians. Lesson 10, Gasket and Seal Basics, Types of Gaskets, Sealants, Proper Installation, and Leak Prevention. Gaskets and seals are essential components in virtually every mechanical system within an automobile, serving the critical function of creating a barrier between mating surfaces, preventing leaks of fluids or gases, and maintaining pressure within systems. While often overlooked, these components are vital for ensuring the proper operation and longevity of engines, transmissions, and other critical systems. This lesson delves into the fundamentals of gaskets and seals, exploring various types, the role of sealants, proper installation techniques, and strategies for preventing leaks. Understanding the principles of gasket and seal design and installation is crucial for any aspiring automotive technician, as improper installation can lead to leaks, component damage, and even catastrophic engine failure. Proper sealing is crucial for many reasons. It can prevent loss of fluids. Gaskets are typically flat, preformed components made from a variety of materials, including rubber, cork, paper, metal, or a composite of materials. They are designed to be compressed between two mating surfaces, filling any imperfections and creating a tight seal. The choice of gasket material depends on the specific application, considering factors such as temperature, pressure, the type of fluid or gas being sealed, and the materials of the mating surfaces. For example, head gaskets, which seal the cylinder head to the engine block, are typically made from multiple layers of steel, along with composite materials, to withstand the high temperatures and pressures of combustion. Exhaust gaskets are often made from metal or heat-resistant composite materials. Intake manifold gaskets may be made from rubber, paper, or composite materials. The correct gasket material is essential. Sealants, on the other hand, are viscous compounds that are applied to mating surfaces, either alone or in conjunction with a gasket, to create a seal. Sealants can be used to fill larger gaps or imperfections than gaskets alone can accommodate. They can also provide additional protection against leaks in high-pressure or high-temperature applications. There are many types of sealants, including anaerobic sealants, which cure in the absence of air, RTV, room temperature vulcanizing, silicone sealants, which cure upon exposure to moisture in the air, and thread sealants, which are used to seal threaded connections. Anaerobic sealants are often used on rigid metal-to-metal joints. RTV silicone is a versatile sealant that can be used in a variety of applications. Thread sealants are commonly used on pipe threads. Choosing the right sealant is crucial. The choice between using a gasket, a sealant, or both depends on the specific application. In some cases, a gasket alone is sufficient to create a proper seal. In other cases, a sealant may be used to supplement the gasket, providing an extra layer of protection. In some applications, a sealant alone may be used, particularly when the mating surfaces are machined to very close tolerances. The manufacturer's recommendations should always be followed when deciding whether to use a gasket, a sealant, or both. Proper surface preparation is also crucial for ensuring a good seal. The mating surfaces must be clean and free of debris. Old gasket material must be completely removed. Proper installation of gaskets and seals is critical for preventing leaks. Before installation, the mating surfaces must be thoroughly cleaned and inspected for any damage, such as scratches, gouges, or warpage. Any imperfections should be addressed before proceeding. Old gasket material or sealant must be completely removed using a scraper or other appropriate tool, taking care not to damage the mating surfaces. A solvent may be used to remove any remaining residue. The surfaces should be clean and dry before installing the new gasket or sealant. Proper cleaning is essential for a good seal. It prevents leaks. When installing a gasket, it is important to ensure that it is properly aligned with the mating surfaces and any bolt holes. The fasteners should be tightened in the correct sequence and to the specified torque, as indicated in the service manual. Uneven tightening can distort the gasket or the components, leading to leaks. In many cases, a specific tightening sequence is required to ensure even pressure distribution across the gasket. This is particularly important for components such as cylinder heads and intake manifolds. Following the correct sequence and torque specifications is crucial for preventing leaks and ensuring proper sealing. Proper installation is key to preventing leaks. When using a sealant, it is important to apply it evenly and in the correct amount. Too much sealant can squeeze out and potentially clog passages or interfere with the operation of components. Too little sealant may not provide a complete seal. The type of sealant used should be appropriate for the specific application, considering factors such as temperature, pressure, and the type of fluid being sealed. The manufacturer's recommendations should always be followed when selecting and applying a sealant. Different sealants have different curing times. It's important to allow sufficient time for the sealant to cure before subjecting the joint to pressure or fluids. Leak prevention is a primary concern in automotive repair, and understanding the principles of gasket and seal design and installation is essential for achieving this goal. Leaks can result in loss of fluids, such as engine oil, coolant, or transmission fluid, leading to component damage or failure. Leaks can also allow contaminants to enter systems, causing further damage. In some cases, leaks can create safety hazards, such as when flammable fluids leak onto hot exhaust components. Properly installed gaskets and seals are the first line of defense against leaks. Regular inspections can help identify potential leaks. In addition to proper installation, regular inspection of gaskets and seals is important for preventing leaks. Over time, gaskets can become brittle or cracked, and seals can deteriorate. Regularly inspecting these components for signs of wear or damage can help identify potential problems before they lead to leaks. When a leak is detected, it is important to identify the source and address it promptly. This may involve replacing a gasket or seal, tightening fasteners, or repairing damage to the mating surfaces. Ignoring a leak can lead to more serious problems. It's important to address leaks promptly. Different types of gaskets are used in various automotive systems, each designed to meet the specific requirements of its application. Head gaskets, as mentioned earlier, are among the most critical gaskets in an engine. They must withstand the extreme temperatures and pressures of the combustion chamber while sealing the cylinder head to the engine block, preventing leaks of coolant, oil, and combustion gases. Head gaskets are typically made of multiple layers of steel, along with composite materials, to provide strength and durability. They are designed to withstand extreme conditions. Proper installation is crucial. Valve cover gaskets seal the valve cover to the cylinder head, preventing oil leaks. These gaskets are often made of rubber or cork and are relatively easy to replace. Oil pan gaskets seal the oil pan to the engine block, preventing oil leaks from the bottom of the engine. These gaskets can be made of various materials, including rubber, cork, or composite materials. Timing cover gaskets seal the timing cover to the engine block, preventing oil leaks from the timing chain or belt area. These gaskets are often made of rubber or composite materials. They must be properly installed. Exhaust gaskets seal the connections between exhaust components, such as the exhaust manifold and the cylinder head, or between sections of exhaust pipe. These gaskets are typically made of metal or heat-resistant composite materials to withstand the high temperatures of exhaust gases. Intake manifold gaskets seal the intake manifold to the cylinder head, preventing vacuum leaks and ensuring proper air-fuel mixture delivery. These gaskets can be made of various materials, including rubber, paper, or composite materials. They are crucial for proper engine operation. They prevent air leaks. Beyond these common types, numerous other gaskets and seals are used throughout a vehicle, including water pump gaskets, fuel pump gaskets, transmission pan gaskets, differential cover gaskets, and various O-rings and seals used in hydraulic and pneumatic systems. Each of these gaskets and seals plays a crucial role in maintaining the integrity of its respective system. Proper selection and installation of these components are essential for preventing leaks and ensuring proper operation. Using the correct gasket or seal is crucial for each application. It ensures a proper seal. Sealants also come in various formulations, each designed for specific applications. Anaerobic sealants cure in the absence of air and are commonly used on rigid, machined metal surfaces, such as those found on transmission cases or differential covers. They provide a strong, durable seal that is resistant to vibration and high pressures. RTV silicone sealants cure upon exposure to moisture in the air and are commonly used for sealing oil pans, valve covers, and other components. They offer good flexibility and resistance to high temperatures. They are versatile sealants. Thread sealants, as the name suggests, are used to seal threaded connections, such as those found on pipe fittings or sensors. They prevent leaks of fluids or gases through the threads. Thread locking compounds, while not strictly sealants, are often used on threaded fasteners to prevent loosening due to vibration. They fill the gaps between the threads, creating a secure connection. They are essential in many applications. They prevent fasteners from coming loose. In conclusion, gaskets and seals are fundamental components that play a critical role in maintaining the integrity and proper operation of various automotive systems. Understanding the different types of gaskets and sealants, their properties, and proper installation techniques is essential for any automotive technician. By meticulously following manufacturers' recommendations and employing best practices for installation and leak prevention, technicians can ensure the quality and reliability of their repairs, contributing to the longevity and safety of the vehicles they service. This lesson has provided a comprehensive overview of gaskets and seals, laying the groundwork for a deeper understanding of their application in specific systems, which will be explored in further detail in subsequent lessons. Mastery of these concepts is essential. Lesson 11, Introduction to OBD2 and Basic Diagnostics. Setting up a scanner, reading basic trouble codes, freeze frame data. The advent of onboard diagnostics, OBD, has revolutionized the automotive repair industry, providing technicians with unprecedented access to vehicle performance data and diagnostic information. The current standard, OBD2, has become an indispensable tool for diagnosing and repairing modern vehicles. This lesson provides an introduction to OBD2 and basic diagnostics, covering the fundamentals of setting up a scan tool, reading basic trouble codes, and interpreting freeze frame data. Understanding these concepts is essential for any aspiring automotive technician, as OBD2 has become the primary means of diagnosing and troubleshooting a wide range of vehicle issues. This technology allows technicians to quickly and accurately identify problems. It is a powerful tool. OBD2, which stands for Onboard Diagnostics 2, is a standardized system that was mandated in the United States for all vehicles sold in 1996 and later. It provides a universal interface for accessing vehicle data, allowing technicians to use a single scan tool to communicate with vehicles from different manufacturers. The system monitors various vehicle parameters and sets diagnostic trouble codes, DTCs, when a problem is detected. These codes can then be retrieved using a scan tool, providing valuable information about the nature and location of the fault. OBD2 was a major advancement in automotive diagnostics. It standardized the diagnostic process. The heart of the OBD2 system is the Data Link Connector, DLC, a 16-pin connector typically located under the dashboard on the driver's side. This connector provides a standardized interface for connecting a scan tool to the vehicle's onboard computer network. The DLC is where the scan tool is connected. It is the gateway to the vehicle's diagnostic information. The location of the DLC is standardized, making it easy to find. A scan tool is an electronic device that communicates with the vehicle's onboard computer through the DLC. Scan tools range in complexity from simple code readers, which can only retrieve and clear DTCs, to sophisticated professional-grade scan tools that can access live data streams, perform bidirectional control tests, and even reprogram control modules. Choosing the right scan tool depends on the specific needs of the technician and the types of vehicles they work on. A basic scan tool is sufficient for reading and clearing codes. More advanced scan tools offer more features. Setting up a scan tool is typically a straightforward process. The first step is to locate the DLC in the vehicle and connect the scan tool's connector to it. Once the connection is established, the scan tool will typically power on automatically. The next step is usually to turn the ignition key to the on position, but without starting the engine. This provides power to the vehicle's computer systems, allowing the scan tool to communicate with them. The scan tool will then typically prompt the user to enter vehicle information, such as the make, model, and year. Some scan tools can automatically detect this information. Proper setup is crucial. Once the scan tool is connected and initialized, it can be used to retrieve diagnostic trouble codes, DTCs. DTCs are alphanumeric codes that correspond to specific faults detected by the OBD2 system. A typical DTC consists of a letter followed by 4 digits, such as P0300. The first letter indicates the system where the fault occurred, P for powertrain, B for body, C for chassis, U for network. The first digit indicates whether the code is generic, 0, or manufacturer-specific, 1. The remaining 3 digits identify the specific fault. DTCs provide valuable clues about the problem. They are the starting point for diagnosis. Generic DTCs are standardized across all manufacturers, meaning that a P0300 code will indicate a random misfire on any vehicle. Manufacturer-specific codes, on the other hand, are unique to each manufacturer and may provide more detailed information about the fault. Many scan tools will provide a brief description of the DTC along with the code itself. This description can be helpful in understanding the nature of the fault. However, it is important to consult the vehicle's service manual for a more detailed explanation of the code and its potential causes. The service manual is the definitive source of information. It provides detailed diagnostic procedures. In addition to retrieving DTCs, many scan tools can also clear them. Clearing codes erases them from the vehicle's computer memory. This can be useful after a repair has been performed to verify that the problem has been resolved. However, it is important to note that clearing codes does not fix the underlying problem. If the fault that caused the code to set is still present, the code will likely return. Clearing codes should only be done after the problem has been addressed. It is not a substitute for proper diagnosis and repair. It is a tool to be used carefully. Freeze frame data is another valuable piece of information that can be retrieved from the OBD2 system. When a DTC is set, the system captures a snapshot of various vehicle parameters at the moment the fault occurred. This snapshot is called freeze frame data. It typically includes information such as engine speed, vehicle speed, coolant temperature, fuel trim values, and other relevant data. Analyzing freeze frame data can provide valuable clues about the conditions that were present when the fault occurred, helping to pinpoint the root cause of the problem. Freeze frame data is like a time capsule. It captures a moment in time. Freeze frame data can be particularly helpful when diagnosing intermittent problems, which may not be present when the vehicle is being inspected. By examining the data captured when the fault occurred, the technician may be able to identify a pattern or a specific set of conditions that trigger the problem. For example, if the freeze frame data shows that the engine was running lean, too much air, not enough fuel, when a misfire code was set, this could indicate a vacuum leak or a problem with the fuel delivery system. Interpreting freeze frame data requires a good understanding of engine operation. It requires knowledge of how different systems interact. Many scan tools also allow access to live data streams, which display real-time readings from various sensors and components. This can be invaluable for diagnosing problems that are not setting DTCs or for monitoring the performance of specific systems. For example, a technician might monitor the oxygen sensor readings to diagnose a fuel mixture problem or observe the transmission temperature to diagnose a shifting issue. Live data provides a real-time view of vehicle operation. It allows technicians to see how systems are performing. It is a powerful diagnostic tool. Using a scan tool effectively requires practice and a solid understanding of automotive systems. It is important to consult the scan tool's user manual to learn about its specific features and functions. Many scan tool manufacturers also offer training courses or online tutorials to help technicians get the most out of their tools. Practice is essential for mastering the use of a scan tool. It takes time to become proficient. The more you use it, the better you'll understand it. Beyond basic code reading and freeze frame data, more advanced scan tools offer a range of additional capabilities. Bidirectional control, for example, allows the technician to command certain components to perform specific actions, such as activating a fuel injector or turning on a cooling fan. This can be useful for testing the operation of individual components or for performing certain diagnostic procedures. Bidirectional control allows for testing components. It can help isolate problems. It requires a good understanding of the system being tested. Some scan tools also have the ability to reprogram control modules, also known as flashing. This involves updating the software in a control module to the latest version or installing a new calibration. Reprogramming may be necessary to address certain software bugs, improve performance, or enable new features. However, reprogramming should only be performed by trained technicians using the correct equipment and procedures, as errors can render the control module inoperable. Reprogramming requires specialized equipment and software. It is not a task for beginners. It should only be done when necessary. In addition to scan tools, other diagnostic tools and resources are available to assist technicians in troubleshooting OBD2-related issues. Online databases, such as those discussed in the previous lesson, often contain detailed diagnostic information, including troubleshooting flowcharts, wiring diagrams, and component location diagrams. These resources can be invaluable for diagnosing complex problems. They provide a wealth of information. They can save time and effort. Furthermore, it is important to remember that OBD2 is just one tool in the diagnostic process. It should be used in conjunction with other diagnostic techniques, such as visual inspection, symptom analysis, and component testing. A thorough understanding of automotive systems and a systematic approach to problem solving are essential for effective diagnosis. OBD2 is a powerful tool, but it is not a magic bullet. It is just one piece of the puzzle. In conclusion, OBD2 has become an indispensable tool for diagnosing and repairing modern vehicles. Understanding how to set up a scan tool, retrieve and interpret diagnostic trouble codes, and analyze freeze-frame data is essential for any automotive technician. This lesson has provided a foundational understanding of these concepts, laying the groundwork for more advanced diagnostic techniques that will be covered in subsequent lessons. By mastering the use of OBD2 and other diagnostic tools, technicians can efficiently and accurately identify and resolve vehicle problems, ensuring customer satisfaction and contributing to the overall quality of automotive repair. This technology is constantly evolving. Technicians must stay up to date. Lesson 12, Performing Routine Maintenance Services, Oil Changes, Filters, Tire Rotations, Basic Inspections, and Scheduling. Routine maintenance is the cornerstone of vehicle longevity and reliability. Regularly scheduled maintenance services, often referred to as preventative maintenance, help to identify and address potential problems before they escalate into major repairs, saving vehicle owners time and money in the long run. This lesson delves into the essential aspects of performing routine maintenance services, covering procedures such as oil changes, filter replacements, tire rotations, and basic inspections. It also explores the importance of adhering to manufacturer-recommended maintenance schedules and the role of the technician in educating customers about the benefits of preventative maintenance. These services are the bread and butter of many shops. They are essential for keeping vehicles running smoothly. They are important for customer retention. Perhaps the most frequent and well-known maintenance service is the oil change. Engine oil plays a crucial role in lubricating the engine's internal components, reducing friction and wear. It also helps to cool the engine, clean internal components by suspending contaminants, and in some cases, seal piston rings. Over time, however, engine oil degrades due to heat, oxidation, and contamination. Regular oil changes, performed at intervals recommended by the vehicle manufacturer, are essential for maintaining engine health and performance. The oil change is a fundamental service. It is one of the most important. It is vital. The oil change process typically involves draining the old oil from the engine, replacing the oil filter, and refilling the engine with the correct type and quantity of new oil. The specific steps may vary slightly depending on the vehicle make and model, but the general procedure remains the same. Before beginning an oil change, it is important to gather all the necessary supplies, including the correct type and quantity of oil, a new oil filter, a wrench to remove the oil drain plug, a container to catch the old oil, and a funnel for adding the new oil. Having everything on hand will make the process smoother. It will also save time. The first step in an oil change is typically to warm up the engine. This helps to thin the oil, allowing it to drain more easily. The vehicle should then be safely lifted using a lift or jack stands, as discussed in Lesson 4. Once the vehicle is safely raised and supported, the oil drain plug, located on the bottom of the oil pan, can be removed, allowing the old oil to drain into a suitable container. It is important to use the correct size wrench to avoid damaging the drain plug. Care should be taken when removing the plug, as the oil may be hot. The oil should be allowed to drain completely. While the oil is draining, the oil filter can be replaced. The oil filter is designed to trap contaminants, such as dirt and metal particles, that can damage the engine. Over time, the filter becomes clogged and needs to be replaced. Most vehicles use a spin-on type oil filter, which can be removed using an oil filter wrench. Before installing the new filter, a light film of clean oil should be applied to the rubber gasket to ensure a good seal. The new filter should then be hand-tightened, followed by an additional quarter to half turn, as specified by the manufacturer. Using the correct filter is crucial. It must be installed correctly. Once the oil has completely drained and the new filter is installed, the drain plug can be reinstalled. It is important to use a new crush washer, if applicable, and to torque the drain plug to the manufacturer's specifications. This prevents leaks and ensures that the plug is not over-tightened and damaged. The vehicle can then be lowered, and the engine can be refilled with the correct type and quantity of new oil. The oil level should be checked using the dipstick and adjusted as needed. After the oil change is complete, the engine should be started and run for a few minutes to allow the oil to circulate. The engine should then be shut off, and the oil level should be checked again and topped off if necessary. The old oil and filter should be disposed of properly. Proper disposal is important for the environment. In addition to oil changes, regular filter replacements are also essential. Besides the oil filter, vehicles have other filters that need periodic replacement, including the air filter, fuel filter, and cabin air filter. The air filter prevents dirt and debris from entering the engine, while the fuel filter traps contaminants in the fuel system. The cabin air filter filters the air that enters the passenger compartment, removing dust, pollen, and other pollutants. Replacing these filters at the recommended intervals is crucial for maintaining optimal engine performance, fuel efficiency, and passenger comfort. Clogged filters can restrict airflow. This can affect performance. Tire rotations are another important maintenance service that helps to promote even tire wear and extend tire life. Tires tend to wear unevenly due to factors such as vehicle weight distribution, driving habits, and road conditions. Rotating the tires involves moving them from one position on the vehicle to another, such as from front to rear or side to side, according to a specific pattern. This helps to distribute wear more evenly across all four tires. The specific rotation pattern depends on the vehicle's drivetrain, front-wheel drive, rear-wheel drive, all-wheel drive, and whether the tires are directional or non-directional. Tire rotations are typically performed every 5,000 to 8,000 miles. They are often done in conjunction with oil changes. During a tire rotation, it is also a good opportunity to inspect the tires for any signs of damage or wear, such as cuts, bulges, or uneven tread wear. The tire pressure should also be checked and adjusted to the manufacturer's recommendations. Proper tire pressure is important for handling, fuel efficiency, and tire life. Tire rotations are a simple but important service. They can extend tire life significantly. They also provide an opportunity for inspection. Basic inspections are an integral part of any routine maintenance service. These inspections involve visually checking various components and systems for signs of wear, damage, or leaks. This can include checking fluid levels, inspecting belts and hoses, examining the brakes, checking the suspension components, and inspecting the exhaust system. Identifying potential problems during a routine inspection can prevent them from escalating into more serious and costly repairs down the road. A thorough inspection is crucial for preventative maintenance. It can catch problems early. It is a valuable service. When performing inspections, it is important to follow a systematic approach, checking each component and system carefully. Fluid levels should be checked against the manufacturer's recommendations and topped off as needed. Belts and hoses should be inspected for cracks, fraying, or other signs of wear. Brake pads and rotors should be examined for wear and damage. Suspension components, such as shocks, struts, and ball joints, should be checked for leaks or excessive play. The exhaust system should be inspected for leaks, rust, or damage. Any problems found during the inspection should be noted and reported to the customer. A detailed inspection report is helpful. It builds customer trust. In addition to performing the maintenance services themselves, technicians also play an important role in educating customers about the importance of preventative maintenance and adhering to the manufacturer's recommended maintenance schedule. This schedule, which can be found in the vehicle's owner's manual, outlines the specific services that should be performed at various mileage or time intervals. Following this schedule helps to ensure that the vehicle remains in optimal condition and that potential problems are addressed before they lead to major repairs. Educating customers about maintenance is crucial. It helps them understand the importance. It can also lead to increased business. Many repair shops offer maintenance packages or service plans that bundle together common maintenance services, such as oil changes, tire rotations, and inspections, at a discounted price. These packages can be a convenient and cost-effective way for customers to keep up with their vehicle's maintenance needs. They can also help to build customer loyalty and generate repeat business. Offering maintenance packages is a good business practice. It benefits both the shop and the customer. It provides a valuable service. In conclusion, performing routine maintenance services is a fundamental aspect of automotive repair. Regular oil changes, filter replacements, tire rotations, and basic inspections are essential for maintaining vehicle health, preventing costly repairs, and ensuring the safety and reliability of the vehicle. By diligently following manufacturer recommendations, employing proper techniques, and educating customers about the importance of preventative maintenance, technicians can contribute to the longevity of vehicles and build lasting relationships with their customers. This lesson has provided a comprehensive overview of routine maintenance services, laying the foundation for a deeper understanding of the specific procedures and techniques involved in each service, which will be explored in greater detail in subsequent lessons. Mastery of these services is essential for any technician. They are performed regularly. Lesson 13, Battery and Charging System Safety, Testing Batteries, Cleaning Terminals, Jumpstart Procedures. The battery and charging system are critical components of a vehicle's electrical system, responsible for starting the engine and powering electrical accessories. Proper maintenance and safe handling of these components are essential for ensuring reliable vehicle operation and preventing accidents. This lesson focuses on the safety aspects of working with batteries and charging systems, covering procedures for testing batteries, cleaning terminals, and performing jump starts. Understanding these procedures and adhering to safety precautions is crucial for any automotive technician, as working with electricity always involves potential hazards. Batteries store a significant amount of energy. They must be handled carefully. The charging system generates high voltage. The battery is essentially an electrochemical storage device that provides the electrical energy needed to start the engine and power electrical accessories when the engine is not running. Most vehicles use lead-acid batteries, which consist of lead plates immersed in an electrolyte solution of sulfuric acid and water. These batteries are relatively inexpensive and can deliver a large amount of current for short periods, making them ideal for starting engines. However, they also require careful handling, as the electrolyte solution is corrosive and can cause burns. The chemical reaction within the battery produces electricity. Batteries can be dangerous if mishandled. They contain acid. When working with batteries, it is essential to wear appropriate personal protective equipment, PPE, including safety glasses and gloves. Safety glasses protect the eyes from splashes of electrolyte solution, while gloves protect the skin. It is also important to work in a well-ventilated area, as batteries can release hydrogen gas, which is flammable. Smoking or creating sparks near a battery should be strictly avoided. Proper ventilation is crucial when working with batteries. Hydrogen gas can be explosive. Safety is paramount. Before performing any work on a battery, it is important to disconnect the battery cables, starting with the negative cable first. This helps to prevent accidental short circuits, which can damage electrical components or cause sparks. When disconnecting the cables, it is important to use the correct size wrench to avoid damaging the terminals. The terminals and cable ends should be inspected for corrosion, which can interfere with the flow of electricity. Corrosion can appear as a white or bluish powdery substance. It can cause poor connections. It must be removed. Corroded battery terminals should be cleaned using a wire brush and a solution of baking soda and water. The baking soda neutralizes the acid in the corrosion, making it easier to remove. The terminals and cable ends should be thoroughly cleaned and dried before the cables are reconnected. Applying a thin layer of petroleum jelly or dielectric grease to the terminals after they are cleaned can help to prevent future corrosion. Proper cleaning ensures a good connection. It prevents voltage drop. It is a simple but important task. Testing a battery is an essential part of diagnosing starting and charging problems. A simple way to test a battery's state of charge is to use a voltmeter. A fully charged 12-volt battery should read approximately 12.6 volts or higher when the engine is off. A reading significantly lower than this indicates that the battery may be discharged or failing. A voltmeter can also be used to test the battery's voltage under load, such as when cranking the engine. A significant voltage drop during cranking can indicate a weak battery. Voltage testing is a basic diagnostic procedure. It can reveal a lot about a battery's condition. It is a quick and easy test. A more accurate way to test a battery's capacity is to use a battery load tester. This device applies a load to the battery, simulating the demands of starting the engine, and measures the battery's ability to maintain voltage under load. A good battery should be able to maintain a voltage above 9.6 volts for 15 seconds under load. Load testing provides a more accurate assessment of a battery's health than a simple voltage test. It can reveal weaknesses that may not be apparent otherwise. It is a more definitive test. Another important test is a specific gravity test, which measures the density of the electrolyte solution in each cell of the battery. This test is performed using a hydrometer, a device that measures the specific gravity of a liquid. The specific gravity of the electrolyte is directly related to the battery's state of charge. A fully charged battery will have a higher specific gravity than a discharged battery. Specific gravity testing is not applicable to sealed batteries. It is only used for batteries with removable caps. It provides a good indication of the battery's state of charge. If a battery is found to be weak or failing, it may need to be replaced. When replacing a battery, it is important to choose the correct size and type for the vehicle. The battery's cold cranking amps, CCA, rating, which indicates its ability to deliver current at low temperatures, should meet or exceed the manufacturer's specifications. The battery's reserve capacity, which indicates how long it can power accessories with the engine off, should also be considered. Choosing the right battery is crucial for reliable starting. It also ensures sufficient power for accessories. It is important to consult the vehicle's owner's manual. Jump-starting a vehicle with a dead battery is a common procedure, but it must be performed correctly to avoid damaging the vehicle's electrical systems or causing injury. Before attempting a jump start, it is important to inspect both batteries and ensure that neither is damaged or leaking. Safety glasses should be worn during the procedure. The vehicles should be parked close enough so that the jumper cables can reach both batteries, but they should not be touching. Both vehicles should be turned off, and the parking brakes should be engaged. Proper jump-starting procedure is essential. It prevents damage and injury. It must be done correctly. The jumper cables should be connected in the following order. First, connect the positive, red, clamp to the positive terminal of the dead battery. Second, connect the other positive, red, clamp to the positive terminal of the good battery. Third, connect the negative, black, clamp to the negative terminal of the good battery. Finally, connect the other negative, black, clamp to a good ground on the vehicle with the dead battery, such as an unpainted metal part of the engine block or chassis. Connecting the negative cable to a ground point away from the battery helps to prevent sparks near the battery, which could ignite hydrogen gas. The order of connection is crucial. It prevents sparking near the battery. It is a safety precaution. Once the cables are connected, the engine of the vehicle with the good battery should be started and allowed to run for a few minutes. This allows some charge to transfer to the dead battery. Then, an attempt can be made to start the engine of the vehicle with the dead battery. If the engine starts, the jumper cables should be removed in the reverse order of connection, being careful not to let the clamps touch each other. The engine of the vehicle that was jump-started should be allowed to run for at least 20 to 30 minutes to allow the alternator to recharge the battery. If the engine does not start after a few attempts, there may be a more serious problem. Further diagnosis may be required. After a jump start, it is a good idea to have the battery and charging system tested to determine the cause of the dead battery. The battery may simply be old and in need of replacement, or there may be a problem with the charging system that is preventing the battery from being properly recharged. Ignoring a charging system problem can lead to repeated dead batteries and potentially damage the alternator. Proper diagnosis is important after a jump start. It can prevent future problems. It is a necessary step. The charging system is responsible for replenishing the battery's charge while the engine is running. The main component of the charging system is the alternator, which converts mechanical energy from the engine into electrical energy. The alternator's output is regulated by a voltage regulator, which ensures that the battery is charged at the correct voltage. A problem with the charging system can prevent the battery from being properly charged, leading to starting problems. The charging system is vital for maintaining battery charge. It also powers the electrical system when the engine is running. It is a crucial system. Testing the charging system typically involves using a voltmeter to measure the voltage at the battery terminals while the engine is running. A healthy charging system should produce a voltage between 13.5 and 14.5 volts. A reading significantly lower than this indicates a problem with the alternator or voltage regulator. A reading higher than 14.5 volts can indicate overcharging, which can damage the battery and other electrical components. Proper testing of the charging system is important. It can identify problems before they cause further damage. It requires a voltmeter. In conclusion, the battery and charging system are essential for reliable vehicle operation, and understanding how to safely work with these components is a crucial skill for any automotive technician. This lesson has covered important safety precautions, procedures for testing batteries, cleaning terminals, and performing jump starts. By adhering to these guidelines and using proper diagnostic techniques, technicians can ensure the safety of themselves and others while effectively maintaining and repairing vehicle electrical systems. The principles discussed in this lesson will be further developed in subsequent lessons, providing a more in-depth understanding of electrical system diagnosis and repair. Safety should always be the top priority when working with electricity. It is important to follow procedures carefully. This lesson provides a good foundation. Lesson 14, Basic Electrical Circuits and Safe Testing Methods using DVOMs, Circuit Continuity, Voltage Drop Checks. Electricity is the lifeblood of modern vehicles, powering everything from the starter motor to complex electronic control systems. As vehicles become increasingly reliant on electronics, a thorough understanding of basic electrical circuits and safe testing methods is more critical than ever for automotive technicians. This lesson delves into the fundamentals of electrical circuits, exploring concepts such as voltage, current, and resistance. It also covers the proper use of digital voltohm meters, DVOMs, circuit continuity testing, and voltage drop checks. These diagnostic techniques are essential for identifying and troubleshooting electrical problems, ensuring the safety of technicians and the proper functioning of vehicle systems. Electrical systems can be complex. They require careful diagnosis. Safety is paramount. An electrical circuit is a closed loop that allows electricity to flow from a power source, through various components, and back to the source. For electricity to flow, there must be a complete, unbroken path. The simplest circuit consists of a power source, such as a battery, a load, such as a light bulb, and connecting wires. The power source provides the electrical energy, the load consumes the energy, and the wires provide the path for the current to flow. Understanding the basic principles of circuits is fundamental to electrical diagnosis. A complete circuit is necessary for current to flow. This is a fundamental concept. Voltage, measured in volts, V, is the electrical potential difference between 2 points in a circuit. It is often described as the pressure that drives the flow of electricity. In a typical automotive electrical system, the battery provides a nominal voltage of 12.6 volts when fully charged. Voltage can be thought of as the force that pushes electrons through a circuit. Higher voltage means a greater force. Voltage is measured using a voltmeter. It is a fundamental electrical property. Current, measured in amperes, A, or amps, is the rate of flow of electrical charge through a circuit. It is the actual movement of electrons through the wires and components. The amount of current flowing through a circuit depends on the voltage and the resistance of the circuit. Current can be thought of as the amount of electrons flowing past a point in a circuit each second. Higher current means more electrons are flowing. Current is measured using an ammeter. Ammeters are typically connected in series. Resistance, measured in ohms, ohm symbol, is the opposition to the flow of current in a circuit. Every component and wire in a circuit has some degree of resistance. The amount of resistance depends on the material, length, and cross-sectional area of the conductor, as well as the temperature. Resistance can be thought of as friction that opposes the flow of electrons. Higher resistance means more opposition to current flow. Resistance is measured using an ohmmeter. It is an inherent property of all conductors. These three fundamental electrical properties, voltage, current, and resistance, are related by Ohm's law, which states that the current through a conductor between 2 points is directly proportional to the voltage across the 2 points and inversely proportional to the resistance between them. This one relationship can be expressed mathematically as I equals V/R, where I is current, V is voltage, and R is resistance. Ohm's law is a fundamental principle of electrical circuits. It is used extensively in diagnostics. It allows for calculation of one value if the other two are known. A digital volt-ohm meter, DVOM, is an essential tool for any automotive technician, providing the ability to measure voltage, current, and resistance. DVOMs are versatile instruments that can be used to diagnose a wide range of electrical problems. They are relatively inexpensive and easy to use. When using a DVOM, it is important to select the correct function and range for the measurement being taken. Using the wrong setting can damage the meter or provide inaccurate readings. Proper use of a DVOM is crucial. It requires understanding its functions. To measure voltage, the DVOM should be set to the DC voltage function, for testing battery voltage in most automotive circuits, or the AC voltage function, for testing certain sensors and circuits, such as the AC voltage output of an alternator. The meter leads are then connected across the component or circuit being tested, with the red lead connected to the positive side and the black lead connected to the negative side. The meter will then display the voltage reading. Voltage measurements are typically performed with the circuit powered. They can help identify opens or shorts. To measure resistance, the DVOM should be set to the ohms function. It is important to disconnect the component or circuit being tested from the power source before measuring resistance. This prevents inaccurate readings and potential damage to the meter. The meter leads are then connected across the component or portion of the circuit being tested. The meter will display the resistance reading. Resistance measurements can be used to check for continuity. They can also be used to check for opens in a circuit. Continuity testing is a specific type of resistance measurement used to determine if a circuit is complete or open. A complete circuit will have a low resistance, typically close to 0 ohms, indicating that there is a continuous path for current to flow. An open circuit will have a very high resistance, often indicated as OL, over limit, on the DVOM, indicating that there is a break in the circuit. Continuity testing is useful for checking wires, fuses, switches, and other components. It can help identify broken wires or poor connections. It is a simple but effective test. Voltage drop testing is another important diagnostic technique that can be performed using a DVOM. A voltage drop is the amount of voltage lost as current flows through a component or a section of a circuit. Excessive voltage drop can indicate a problem, such as high resistance due to corrosion, loose connections, or damaged wiring. Voltage drop testing can help pinpoint the location of these problems. Voltage drop is a common cause of electrical problems. It can be caused by a variety of factors. It is important to understand how to test for it. To perform a voltage drop test, the DVOM is set to the DC voltage function. The circuit being tested must be powered and operating under load. One meter lead is connected to the positive side of the power source, and the other lead is connected to the positive side of the load. The meter will then display the voltage drop across that section of the circuit. A small voltage drop is normal, but excessive voltage drop indicates a problem. Voltage drop tests are performed under load. They can reveal hidden resistance. They are a valuable diagnostic tool. When performing any electrical testing, it is crucial to follow safety precautions. Always disconnect the battery when working on electrical components, unless specifically instructed otherwise by the service manual. Wear appropriate PPE, such as safety glasses, and avoid creating sparks near the battery. Be aware of the potential for electrical shock and take necessary precautions to avoid it. Safety should always be the top priority when working with electricity. It is important to follow procedures carefully. Always disconnect the power source when possible. It is also important to consult the vehicle's service manual for specific diagnostic procedures and specifications. Different manufacturers may have different testing methods and acceptable values for voltage, resistance, and voltage drop. The service manual is the definitive source of information for a particular vehicle. It should always be consulted before performing any electrical testing or repairs. It provides detailed information on the vehicle's electrical system. It is an essential resource. In addition to using a DVOM, other tools and techniques can be used for diagnosing electrical problems. Test lights are simple devices that can be used to check for the presence of voltage. However, they do not provide a quantitative measurement and should not be used on sensitive electronic components. Jumper wires can be used to bypass suspected components or sections of a circuit, but care must be taken to avoid creating short circuits. Using the wrong gauge wire can cause problems. It is important to use caution when using jumper wires. In conclusion, understanding basic electrical circuits and safe testing methods is essential for any automotive technician. This lesson has covered fundamental concepts such as voltage, current, and resistance, as well as the proper use of DVOMs for measuring these properties. Techniques such as continuity testing and voltage drop checks have been introduced, providing technicians with valuable tools for diagnosing electrical problems. By adhering to safety precautions, consulting service information, and employing a systematic approach to diagnosis, technicians can effectively troubleshoot electrical issues and ensure the proper functioning of vehicle systems. The principles discussed in this lesson will be further developed in subsequent lessons, building a more comprehensive understanding of automotive electrical systems and diagnostics. Mastery of these concepts is crucial. Lesson 15, Workplace etiquette and professional communication. Brief on interacting with peers, minimal coverage on customer interaction. While technical skills are undoubtedly essential for success in the automotive repair industry, the ability to interact professionally with colleagues and maintain a positive work environment is equally crucial. Workplace etiquette and professional communication are the cornerstones of a productive and harmonious shop, fostering teamwork, mutual respect, and a positive atmosphere that ultimately benefits both employees and customers. This lesson explores the importance of workplace etiquette and professional communication in the automotive repair setting, focusing primarily on interactions with peers and offering minimal coverage of customer interaction. It will delve into various aspects of professional conduct, emphasizing the significance of respect, communication, teamwork, and maintaining a positive attitude in a demanding work environment. These skills are essential for building a strong team. They are often overlooked. Effective communication is the foundation of any successful workplace, and the automotive repair shop is no exception. Clear, concise, and respectful communication between technicians, service advisors, and other shop personnel is essential for ensuring that repairs are performed correctly, efficiently, and safely. Miscommunication can lead to errors, delays, and conflicts, ultimately impacting the quality of work and customer satisfaction. Therefore, mastering the art of professional communication is just as important as mastering technical skills. Communication is key to a successful shop. It prevents misunderstandings. It is a vital skill. In a busy shop environment, it is crucial to communicate clearly and directly with colleagues. When requesting assistance, providing instructions, or sharing information about a repair, be precise and avoid ambiguity. Use proper terminology and avoid slang or jargon that may not be understood by everyone. When asking for help, clearly state the problem and what assistance you need. When providing instructions, ensure they are easy to understand and follow. When sharing information, be thorough and accurate. Clear communication prevents errors and saves time. It is essential for efficient workflow. Active listening is another critical component of effective communication. Pay attention to what your colleagues are saying, both verbally and non-verbally. Make an effort to understand their perspective, even if you don't necessarily agree with it. Ask clarifying questions if needed, and avoid interrupting. Active listening shows respect and helps to prevent misunderstandings. It also allows you to learn from your colleagues. It is a crucial part of communication. It shows that you value what others have to say. Written communication also plays a role in the automotive repair environment, particularly in the form of repair orders, technical reports, and internal memos. When writing, use proper grammar and spelling, and ensure that your message is clear, concise, and easy to understand. Avoid using overly technical language that may not be understood by everyone who needs to read the document. Properly written communication is essential for documentation. It also reflects professionalism. It ensures that information is conveyed accurately. Respect for colleagues is a fundamental aspect of workplace etiquette. Treat everyone in the shop with courtesy and consideration, regardless of their position or experience level. Avoid gossip, rumors, and negative comments about others. Such behavior can create a toxic work environment and damage morale. Instead, focus on building positive relationships with your colleagues, based on mutual respect and trust. Respect should be shown to everyone. It is the foundation of a positive work environment. It creates a more pleasant atmosphere. Teamwork is essential in an automotive repair shop, where technicians often need to collaborate on complex repairs or share tools and equipment. Be willing to help your colleagues when needed, and don't be afraid to ask for help when you need it. Share your knowledge and expertise with others, and be open to learning from them in return. A collaborative environment benefits everyone, fostering a sense of camaraderie and shared purpose. Teamwork makes the job easier. It also improves the quality of work. It is essential for success. Maintaining a positive attitude, even under pressure, is another important aspect of workplace etiquette. The automotive repair industry can be demanding, with tight deadlines and challenging repairs. However, maintaining a positive and professional demeanor can help to diffuse stress and improve morale. Avoid complaining or negativity, and focus on finding solutions to problems. A positive attitude is contagious. It can make a big difference in the workplace. It can improve morale and productivity. Punctuality and reliability are also crucial for maintaining a professional image and contributing to a smooth workflow. Arrive at work on time and ready to work. If you are going to be late or absent, notify your supervisor as soon as possible. Being reliable means that your colleagues can count on you to do your job and to be there when you are needed. Punctuality shows respect for your colleagues and your employer. It is a sign of professionalism. It is important to be reliable. Keeping the work area clean and organized is another important aspect of workplace etiquette. A clean and organized shop is not only safer but also more efficient. Tools and equipment should be put away after use, and spills should be cleaned up immediately. A cluttered workspace can lead to accidents and lost tools. Maintaining a clean workspace shows respect for your colleagues and your work environment. It also makes it easier to find what you need. It is a good habit to develop. Proper handling of tools and equipment is also a sign of professionalism. Tools should be used correctly and for their intended purpose. Avoid using tools that are damaged or worn, as this can be dangerous and can lead to inaccurate repairs. Expensive equipment, such as diagnostic tools, should be handled with care and stored properly when not in use. Proper tool handling prevents damage and accidents. It also shows respect for the equipment. It is a sign of a skilled technician. In addition to interacting with colleagues, technicians may also have some limited interaction with customers. While service advisors typically handle most customer communication, technicians may occasionally be called upon to explain a repair or answer a customer's question. When interacting with customers, it is important to be polite, respectful, and professional. Explain technical issues in a clear and concise manner, avoiding jargon or overly technical language. Listen attentively to the customer's concerns and address them to the best of your ability. Even brief interactions with customers can leave a lasting impression. Professionalism is always important. It reflects well on the shop. While this lesson primarily focuses on interactions with peers, it's important to remember that the principles of professional communication and etiquette also apply to customer interactions. Maintaining a professional demeanor, even in brief encounters, can contribute to a positive customer experience and enhance the reputation of the shop. Customers appreciate being treated with respect. They also appreciate clear communication. These interactions can impact customer satisfaction. Furthermore, maintaining a professional appearance is also important. While automotive repair can be a dirty job, technicians should strive to maintain a clean and presentable appearance. This includes wearing a clean uniform, if provided, and practicing good personal hygiene. A professional appearance instills confidence in customers and reflects positively on the shop. It shows that you take pride in your work. It is a sign of respect for yourself and your profession. Finally, a commitment to continuous learning and professional development is a hallmark of a true professional. The automotive industry is constantly evolving, with new technologies and systems being introduced regularly. Technicians who are committed to staying up to date with the latest advancements will be better equipped to handle the challenges of modern automotive repair. Continuous learning is essential for success in this field. It allows technicians to stay ahead of the curve. It is a sign of a dedicated professional. In conclusion, workplace etiquette and professional communication are essential skills for any automotive technician. By treating colleagues with respect, communicating clearly and effectively, working as a team, and maintaining a positive attitude, technicians can contribute to a productive and harmonious work environment. These skills, combined with technical expertise, are the foundation of a successful career in the automotive repair industry. This lesson has provided an overview of the key principles of workplace etiquette and professional communication, emphasizing their importance in the context of an automotive repair shop. By mastering these principles, technicians can enhance their professional image, build strong relationships with their colleagues, and contribute to the overall success of the shop. This is a valuable lesson for any aspiring technician. These skills are just as important as technical skills. They will contribute to a successful career. Lesson 16, Hazardous Materials and Waste Disposal, Handling Chemicals, Disposing of Used Fluids, Environmental Regulations. The automotive repair industry relies on various chemicals and fluids to perform essential maintenance and repair tasks. However, many of these substances are hazardous, posing risks to human health and the environment if not handled and disposed of properly. This lesson focuses on the critical aspects of hazardous materials and waste disposal in the automotive repair setting, covering safe handling procedures for chemicals, proper disposal methods for used fluids, and the importance of adhering to environmental regulations. Understanding and following these guidelines is not just a matter of legal compliance, it is a fundamental responsibility of every automotive technician to protect themselves, their colleagues, the environment, and the community. Proper handling and disposal are crucial. These materials can be dangerous. Safety is paramount. Automotive repair shops utilize a wide range of chemicals, including solvents, cleaners, lubricants, paints, and adhesives. Many of these substances are flammable, corrosive, toxic, or otherwise hazardous. Therefore, it is crucial to handle them with extreme care, following proper safety procedures and wearing appropriate personal protective equipment, PPE. Before using any chemical, it is essential to read and understand the Safety Data Sheet, SDS, for that product. The SDS provides comprehensive information about the chemical's properties, hazards, safe handling procedures, and emergency response measures. SDSs are required by law. They are a vital source of information. They should be readily available. When handling chemicals, it is important to wear appropriate PPE, such as gloves, safety glasses, and respirators, as indicated on the SDS. Gloves should be made of a material that is resistant to the specific chemical being used. Safety glasses protect the eyes from splashes and fumes. Respirators may be necessary when working with volatile chemicals that produce harmful vapors. Proper ventilation is also crucial when working with chemicals. Work areas should be well ventilated to prevent the buildup of fumes. Exhaust fans or other ventilation systems should be used when necessary. Proper ventilation protects the technician's health. It is essential for safety. It is a crucial aspect of handling chemicals. Chemicals should be stored properly in designated storage areas that are well ventilated, cool, and dry. Containers should be clearly labeled with the chemical name and hazard warnings. Flammable chemicals should be stored in approved flammable storage cabinets, away from sources of ignition. Incompatible chemicals should be stored separately to prevent dangerous reactions. Proper storage is essential for preventing accidents. It also helps to maintain the integrity of the chemicals. It is a crucial aspect of shop safety. In addition to handling chemicals safely, automotive technicians must also be aware of the proper procedures for disposing of used fluids. Used engine oil, transmission fluid, coolant, brake fluid, and other automotive fluids are considered hazardous waste and must be disposed of in accordance with federal, state, and local regulations. These fluids can contaminate soil and groundwater if disposed of improperly, posing a threat to the environment and public health. Proper disposal is not just a good idea. It is the law. It protects the environment. Used oil is one of the most common types of hazardous waste generated by automotive repair shops. It should be collected in designated containers that are clearly labeled used oil. These containers should be kept closed except when adding or removing oil. Used oil can be recycled and re-refined into new lubricating oil, making it a valuable resource. Many repair shops have on-site used oil storage tanks, and the oil is periodically collected by a licensed recycling company. Used oil can be recycled. It is a valuable resource. It should be disposed of properly. Used coolant, also known as antifreeze, is another common type of hazardous waste. It should be collected in separate containers and labeled appropriately. Some recycling companies accept used coolant, which can be filtered, reconditioned, and reused. However, it is important to ensure that the coolant is not contaminated with other fluids, such as oil or brake fluid, as this can make it unsuitable for recycling. Used coolant can be recycled. It should not be poured down the drain. Proper disposal is essential. Used brake fluid is also considered hazardous waste and should be collected and disposed of properly. It should not be mixed with other fluids, such as used oil or coolant. Some recycling companies accept used brake fluid, which can be processed and reused in other applications. Used brake fluid should be stored in a separate container. It should be clearly labeled. It should be disposed of according to regulations. Other automotive fluids, such as transmission fluid, power steering fluid, and differential oil, should also be collected and disposed of as hazardous waste. These fluids can often be recycled along with used oil. It is important to check with local recycling facilities to determine their specific requirements for accepting these fluids. Proper disposal of all automotive fluids is crucial. It is a responsibility that technicians must take seriously. It is important to follow all regulations. In addition to used fluids, other types of hazardous waste are generated in automotive repair shops, such as used oil filters, batteries, tires, and aerosol cans. Each of these items has specific disposal requirements. Used oil filters, for example, should be drained of oil and then recycled as scrap metal. Batteries should be recycled through designated collection programs. Tires can often be recycled into various products, such as playground surfaces or road construction materials. Aerosol cans should be completely emptied and then disposed of according to local regulations. Proper disposal of all waste is important. It is part of being a responsible technician. Adhering to environmental regulations is not just a matter of ethical responsibility, it is also a legal requirement. The Environmental Protection Agency, EPA, and state and local agencies enforce regulations governing the handling and disposal of hazardous waste. Failure to comply with these regulations can result in significant fines and penalties. It is important for repair shops to have a thorough understanding of all applicable regulations and to implement procedures to ensure compliance. Compliance with environmental regulations is crucial. It protects the environment and avoids penalties. It is a legal obligation. To ensure compliance, repair shops should develop and implement a comprehensive hazardous waste management plan. This plan should outline procedures for identifying, handling, storing, and disposing of all hazardous waste generated by the shop. The plan should also include employee training on proper procedures and emergency response measures. Regular inspections should be conducted to ensure that the plan is being followed and that all hazardous waste is being handled and disposed of properly. A well-developed plan is essential. It should be reviewed and updated regularly. It should be followed by all employees. Employee training is a critical component of any hazardous waste management plan. All employees who handle or are potentially exposed to hazardous materials should receive thorough training on the hazards associated with these materials, safe handling procedures, proper use of PPE, and emergency response procedures. Training should be documented and repeated periodically to reinforce the information and ensure that employees remain up to date on the latest regulations and best practices. Proper training is essential for safety. It also ensures compliance with regulations. It is an ongoing process. In addition to formal training, it is important to foster a culture of safety and environmental responsibility within the shop. This includes encouraging employees to report any spills, leaks, or other potential hazards, and to take an active role in ensuring that all hazardous materials are handled and disposed of properly. Open communication and a commitment to continuous improvement are essential for maintaining a safe and environmentally responsible workplace. Safety should be a top priority. It should be a shared responsibility. It should be part of the shop culture. In conclusion, the proper handling and disposal of hazardous materials and waste are critical aspects of automotive repair. By understanding the hazards associated with various chemicals and fluids, following safe handling procedures, using appropriate PPE, and adhering to environmental regulations, technicians can protect themselves, their colleagues, and the environment. This lesson has provided a comprehensive overview of the key principles of hazardous materials management in the automotive repair setting, emphasizing the importance of training, proper disposal methods, and compliance with regulations. The knowledge gained in this lesson will be essential for any aspiring automotive technician, providing a foundation for safe and responsible practices throughout their career. This is a crucial aspect of the job. It cannot be overlooked. Lesson 17, Thread Locking and Sealing Compounds, Selecting and Applying Thread Lockers, Sealants, Anti-Seize Compounds. In the world of automotive repair, ensuring the integrity of threaded connections is paramount. Vibration, temperature fluctuations, and stress can all contribute to fasteners loosening over time, potentially leading to component failure or safety hazards. Thread locking and sealing compounds play a crucial role in preventing such issues, providing a reliable means of securing threaded connections and preventing leaks. This lesson delves into the realm of thread locking and sealing compounds, exploring various types, including thread lockers, sealants, and anti-seize compounds. It will cover the principles behind their operation, proper selection criteria for different applications, and best practices for application to ensure optimal performance and longevity of threaded connections. Choosing the right compound is crucial. Proper application is essential. These compounds are vital. Thread lockers are adhesive compounds specifically designed to prevent loosening of threaded fasteners due to vibration, shock, or thermal cycling. They fill the spaces between the threads, creating a secure bond that resists movement and prevents the fastener from backing out. Thread lockers are typically liquid or semi-solid compounds that are applied to the threads of a fastener before assembly. Once the fastener is tightened, the thread locker cures, forming a strong bond that locks the threads in place. Thread lockers are available in various strengths, ranging from low-strength formulations that allow for disassembly with hand tools to high-strength formulations that create a permanent bond. The strength of the thread locker should be chosen based on the specific application. Low-strength thread lockers are typically used for fasteners that may need to be removed for maintenance or adjustment. Medium-strength thread lockers are suitable for most general-purpose applications. High-strength thread lockers are used for permanent assemblies. One of the most common types of thread locker is anaerobic, meaning it cures in the absence of air. Anaerobic thread lockers are typically used on metal fasteners and cure when confined between the threads of the fastener and the mating component. They are available in various strengths, indicated by color-coded bottles, e.g., blue for medium strength, red for high strength. The specific strength required depends on the size and type of fastener, the materials being joined, and the anticipated load and vibration. It is important to consult the manufacturer's recommendations when selecting a thread locker. Using the wrong strength can lead to problems. It can make disassembly difficult or impossible. Another type of thread locker is a pre-applied thread locker, which comes as a dry coating on the threads of the fastener. These coatings are typically activated by the shearing force during installation, releasing a resin that cures and locks the threads in place. Pre-applied thread lockers are often used in high-volume manufacturing applications, as they eliminate the need for manual application of liquid thread lockers. They provide a consistent and reliable bond. They are often color-coded to indicate strength. They are convenient to use. Thread sealants, as the name implies, are used to seal threaded connections, preventing leaks of fluids or gases. They are commonly used on pipe threads, fittings, and other components where a fluid-tight seal is required. Like thread lockers, thread sealants fill the spaces between the threads, creating a barrier that prevents leakage. Thread sealants are available in various formulations, including pastes, tapes, and dopes. The choice of sealant depends on the specific application, considering factors such as the type of fluid or gas being sealed, the operating temperature and pressure, and the materials of the components. Proper sealant selection is crucial. It prevents leaks and ensures proper operation. One common type of thread sealant is PTFE, polytetrafluoroethylene, tape, also known as Teflon tape. This thin, white tape is wrapped around the threads of a male fitting before assembly, creating a seal when the fitting is tightened into a female fitting. PTFE tape is inexpensive, easy to use, and effective for sealing a wide range of fluids and gases. However, it is important to apply the tape correctly, wrapping it in the direction of the threads to prevent it from unraveling during installation. PTFE tape is commonly used on plumbing fittings. It is also used in automotive applications. It is a versatile sealant. Another type of thread sealant is pipe dope, a paste-like compound that is applied to the threads before assembly. Pipe dope provides both sealing and lubricating properties, making it easier to tighten the fitting and preventing galling of the threads. Pipe dope is available in various formulations for different applications, such as sealing water, oil, or natural gas. It is important to choose a pipe dope that is compatible with the specific fluid or gas being sealed. Pipe dope is often used on larger fittings. It provides a more robust seal than tape. It is also used in high-pressure applications. Anti-seize compounds are another important category of thread treatment compounds. Unlike thread lockers and sealants, which are designed to create a bond or seal, anti-seize compounds are designed to prevent seizing, galling, and corrosion of threaded connections, particularly in high-temperature or corrosive environments. They are typically applied to the threads of fasteners that may need to be disassembled in the future, such as spark plugs, exhaust manifold bolts, and wool studs. Anti-seize compounds make disassembly easier. They prevent damage to threads. They are essential in many applications. Anti-seize compounds are typically composed of a grease or oil base with suspended solid lubricant particles, such as copper, nickel, aluminum, or graphite. These particles create a barrier between the mating surfaces, preventing metal-to-metal contact and reducing friction. The choice of anti-seize compound depends on the specific application, considering factors such as temperature, the presence of corrosive substances, and the materials of the components. Copper-based anti-seize is commonly used for spark plugs. Nickel-based anti-seize is suitable for high-temperature applications. Aluminum-based anti-seize is often used on aluminum components. Proper application of thread locking and sealing compounds is crucial for achieving optimal performance. Before applying any compound, it is important to ensure that the threads are clean and free of oil, grease, dirt, or other contaminants. A solvent or degreaser can be used to clean the threads. The compound should then be applied according to the manufacturer's instructions. For liquid thread lockers, a small amount is typically applied to the first few threads of the male fastener. For sealants, the compound may be applied to both the male and female threads. For anti-seize compounds, a thin, even coating should be applied to the threads. Proper application ensures effectiveness. It prevents problems. It is important to avoid over-applying thread locking or sealing compounds. Excess compound can squeeze out during assembly and potentially contaminate other components or clog passages. In the case of thread lockers, too much compound can make it difficult or impossible to disassemble the fastener later. For sealants, excess compound can create a messy appearance and may not improve the sealing performance. For anti-seize compounds, over-application can attract dirt and debris. Using the correct amount of compound is crucial. It is important to follow the manufacturer's recommendations. After applying the compound, the fastener should be assembled and tightened to the specified torque. It is important to allow sufficient time for the compound to cure before subjecting the connection to load or pressure. Curing times vary depending on the specific product and the ambient temperature. Refer to the manufacturer's instructions for specific curing time recommendations. Proper curing is essential for optimal performance. It ensures a strong and reliable connection. It allows the compound to reach its full strength. In some cases, it may be necessary to remove a fastener that has been treated with a thread locking compound. For low and medium strength thread lockers, this can usually be accomplished using hand tools. However, for high-strength thread lockers, it may be necessary to apply heat to the fastener to soften the compound before it can be removed. A heat gun or torch can be used, but care must be taken to avoid damaging surrounding components. Heating the fastener breaks down the thread locker. It allows for easier removal. It is important to use caution when applying heat. In conclusion, thread locking and sealing compounds play a vital role in ensuring the security and integrity of threaded connections in automotive applications. By understanding the different types of compounds available, their properties, and proper application techniques, technicians can prevent loosening of fasteners, leaks, and component damage. This lesson has provided a comprehensive overview of thread lockers, sealants, and anti-seize compounds, highlighting their importance in various repair scenarios. The knowledge gained in this lesson will be invaluable for any aspiring automotive technician, providing a solid foundation for working with threaded connections and ensuring the long-term reliability of repairs. Proper selection and application of these compounds are crucial for success. It is an important aspect of quality workmanship. This lesson is essential for all technicians. Lesson 18, Introduction to Vehicle Inspection Checklists, Basic Multi-Point Inspections, Typical Pass/Fail Criteria. Vehicle inspections are a crucial aspect of automotive maintenance and repair, providing a systematic way to assess the overall condition of a vehicle and identify potential problems before they escalate into major repairs or safety hazards. A comprehensive inspection can reveal wear and tear, fluid leaks, damaged components, and other issues that may not be readily apparent during normal driving. This lesson introduces the concept of vehicle inspection checklists, focusing on basic multi-point inspections and the typical pass/fail criteria used to evaluate the condition of various vehicle systems and components. Mastering the use of inspection checklists and understanding the criteria for evaluating vehicle condition are essential skills for any aspiring automotive technician, enabling them to perform thorough assessments and provide informed recommendations to customers. Regular inspections are vital for preventative maintenance. They can identify problems early. They are a valuable service. A multi-point inspection is a standardized procedure that involves checking a predetermined list of items on a vehicle. These inspections are typically performed as part of routine maintenance services, such as oil changes, or as a standalone service to provide customers with an overview of their vehicle's condition. The specific items included in a multi-point inspection can vary depending on the repair shop and the type of vehicle, but they generally cover key areas such as fluid levels, tires, brakes, suspension, lights, belts, hoses, and exhaust. Many shops use pre-printed or electronic checklists to ensure consistency and thoroughness. These checklists serve as a guide for technicians. They help ensure that nothing is overlooked. They are an important tool. The first step in performing a multi-point inspection is to gather the necessary tools and information. This typically includes the inspection checklist, a pen or electronic device for recording findings, a flashlight, a tire pressure gauge, a tread depth gauge, and any other specialized tools that may be required. It is also helpful to have access to the vehicle's service history, which can provide valuable information about previous repairs and maintenance. Having all the necessary tools and information on hand will streamline the inspection process. It will also ensure accuracy. It is important to be prepared. The inspection process typically begins with a visual examination of the vehicle's exterior. This includes checking the body for damage, such as dents, scratches, or rust. The condition of the paint, glass, and lights should also be assessed. Any damage or defects should be noted on the inspection checklist. The tires are another crucial area of inspection. The technician should check the tire pressure using a gauge and compare it to the manufacturer's recommended pressure, which is typically found on a sticker inside the driver's side door or in the owner's manual. Tire pressure should be adjusted as needed. Proper tire pressure is crucial for safety and fuel efficiency. It also affects tire wear. The tires should also be inspected for tread depth using a tread depth gauge. Adequate tread depth is essential for maintaining traction, especially in wet or slippery conditions. The legal minimum tread depth is typically 2/32 of an inch, but many experts recommend replacing tires when the tread depth reaches 4/32 of an inch. In addition to tread depth, the tires should be examined for signs of uneven wear, such as cupping or feathering, which can indicate alignment or suspension problems. The tires should also be inspected for any damage, such as cuts, bulges, or embedded objects. Tire inspections are crucial for safety. They can reveal a variety of problems. They should be performed regularly. Next, the inspection typically moves to the underhood area. The technician should check the levels and condition of all fluids, including engine oil, coolant, brake fluid, power steering fluid, and windshield washer fluid. Low fluid levels can indicate leaks or neglect, while contaminated fluids may require replacement. The condition of the belts and hoses should also be assessed. Belts should be inspected for cracks, fraying, or glazing, while hoses should be checked for leaks, bulges, or soft spots. Any worn or damaged belts or hoses should be replaced. The battery should also be inspected, checking for corrosion on the terminals and ensuring that the battery is securely mounted. A visual inspection can reveal many potential problems. It is a crucial part of the process. The inspection then proceeds to the undercarriage of the vehicle. This typically requires lifting the vehicle on a hoist or using jack stands. Once the vehicle is safely raised, the technician can inspect the suspension components, including shocks, struts, ball joints, and control arm bushings. These components should be checked for leaks, damage, or excessive wear. The exhaust system should also be inspected for leaks, rust, or damage. The brakes are another critical area of inspection. The technician should measure the thickness of the brake pads and rotors and compare them to the manufacturer's specifications. Worn brake pads or rotors should be replaced. The brake lines and hoses should also be inspected for leaks or damage. Inspecting the undercarriage requires care and attention to detail. It can reveal hidden problems. It is essential for safety. The interior of the vehicle should also be inspected. This includes checking the operation of all lights, including headlights, taillights, brake lights, turn signals, and interior lights. The operation of the windshield wipers and washers should also be checked. The condition of the seats, seat belts, and other interior components should be assessed. Any problems or defects should be noted on the inspection checklist. The interior inspection is often overlooked. It is important for overall vehicle condition. It can reveal safety issues. Once the inspection is complete, the technician should review the findings and discuss them with the customer. Any items that require immediate attention should be brought to the customer's attention, along with an explanation of the problem and the recommended course of action. The technician should also provide an estimate of the cost of any necessary repairs. It is important to communicate clearly and honestly with the customer, explaining the findings in a way that they can understand. Transparency builds trust. It is important to explain the implications of each finding. It helps the customer make informed decisions. In addition to identifying problems, the inspection process should also include noting items that are in good condition or that meet the manufacturer's specifications. This provides the customer with a complete picture of their vehicle's condition and can help to build trust and confidence in the repair shop. Providing a comprehensive report is important. It shows thoroughness and professionalism. It helps the customer understand the overall condition of their vehicle. It is also important to understand the typical pass/fail criteria used in vehicle inspections. These criteria can vary depending on the specific component or system being inspected, but they generally involve comparing the observed condition to the manufacturer's specifications or industry standards. For example, Brake pads may be considered to have failed if their thickness is below a certain minimum, such as 3/32 of an inch. Tires may be considered to have failed if their tread depth is below the legal minimum of 2/32 of an inch. Fluid leaks are generally considered a failure, regardless of their severity. Understanding pass/fail criteria is crucial. It ensures consistency and accuracy. Many states and municipalities have specific regulations regarding vehicle inspections, particularly for safety and emissions inspections. These regulations often specify the items that must be inspected and the criteria for passing or failing each item. Technicians should be familiar with all applicable regulations in their area. Compliance with these regulations is essential for operating a legitimate repair shop. It is also important for ensuring the safety of vehicles on the road. Regulations can vary from state to state. In addition to performing multi-point inspections, technicians should also be able to perform more focused inspections based on specific customer concerns or symptoms. For example, if a customer complains of a noise coming from the suspension, the technician should be able to perform a targeted inspection of the suspension components to identify the source of the noise. This may involve test driving the vehicle, using specialized tools, or performing additional diagnostic procedures. Focused inspections require a deeper understanding of vehicle systems. They often require more specialized skills. They are an important part of diagnostics. In conclusion, vehicle inspections are a critical aspect of automotive maintenance and repair. Multi-point inspections provide a systematic way to assess the overall condition of a vehicle, while understanding pass/fail criteria ensures that inspections are performed consistently and accurately. By mastering the use of inspection checklists, performing thorough visual examinations, and effectively communicating findings to customers, technicians can identify potential problems, prevent costly repairs, and enhance vehicle safety and reliability. This lesson has provided an introduction to vehicle inspections, laying the groundwork for more advanced diagnostic techniques that will be covered in subsequent lessons. Inspections are a fundamental part of automotive service. They are essential for maintaining vehicle health. Lesson 19, Documentation and Repair Orders, Minimal Coverage on Writing Repair Orders and Tracking Work. While the physical act of repairing vehicles is the most visible aspect of an automotive technician's job, accurate and thorough documentation is equally crucial for ensuring smooth shop operations, maintaining accurate vehicle service histories, and fostering clear communication with customers. This lesson provides an introduction to the importance of documentation in the automotive repair industry, focusing on the basics of writing repair orders and tracking work, with minimal coverage of these topics as per the overall course instructions. Although this lesson will only briefly touch upon these subjects, their significance in the broader context of automotive repair cannot be overstated. Proper documentation is essential for various reasons. It ensures accuracy and accountability. It is a vital part of the business. A repair order, RO, is the primary document used to record and track repairs performed on a vehicle. It serves as a contract between the repair shop and the customer, authorizing the shop to perform specific repairs and outlining the estimated cost. The RO also serves as a record of the work performed, parts used, and labor charges, providing a detailed history of the service performed on the vehicle. Accurate and detailed repair orders are essential for maintaining accurate records. They are also crucial for billing and inventory management. They provide a clear record of the work performed. Although the service advisor typically handles the creation of the repair order, technicians play a vital role in providing accurate information to ensure the RO reflects the work needed. This includes accurately describing the customer's concerns, the diagnosis performed, the recommended repairs, and any parts needed. This information must be communicated clearly and concisely to the service advisor, who will then translate it into the formal repair order. The technician's input is crucial for creating an accurate RO. It ensures that the customer understands the work needed. It also ensures that the correct repairs are authorized. When documenting the customer's concerns, it is important to be as specific as possible, noting the symptoms described by the customer, when they occur, and under what conditions. For example, instead of simply writing "noise from engine," the technician might note, "Customer reports a rattling noise from the engine compartment when accelerating from a stop, most noticeable when the engine is cold." This detailed description helps the technician who will be performing the diagnosis and repair to understand the problem more accurately. Detailed descriptions are crucial for proper diagnosis. They help to pinpoint the problem. They save time and effort. Once the technician has diagnosed the problem, they must document their findings on the repair order, including the cause of the problem and the recommended repairs. This should be written in clear, concise language that is easy for the service advisor and the customer to understand. Technical jargon should be avoided or explained in simple terms. The technician should also list any parts that will be needed for the repair, including part numbers and quantities. Accurate diagnosis and clear documentation are essential. They ensure that the correct repairs are performed. They also ensure that the customer is properly informed. In addition to documenting the repairs needed, the repair order should also include an estimate of the cost of the repairs. This estimate should include both parts and labor charges. The labor charges are typically calculated based on a predetermined labor rate and the estimated time required to perform the repairs, often obtained from a labor time guide. The parts prices are typically obtained from a parts catalog or database. Providing an accurate estimate is crucial for customer satisfaction. It helps to avoid surprises when the final bill is presented. It is important to be transparent about pricing. Once the repair order has been created and approved by the customer, it serves as a roadmap for the technician performing the repairs. The technician should carefully follow the instructions on the repair order, ensuring that all authorized repairs are performed correctly and that the correct parts are used. Any deviations from the repair order should be documented and communicated to the service advisor. Following the RO ensures that the correct work is performed. It also ensures that the customer is billed accurately. It is a crucial part of the repair process. As the technician performs the repairs, they should keep track of the time spent on each task. This information is used to calculate the labor charges on the final invoice. Many shops use a computerized system to track labor time, allowing technicians to clock in and out of each job. Accurate time tracking is essential for proper billing. It also helps the shop to monitor efficiency. It is important to be honest and accurate when tracking time. In addition to tracking labor time, the technician should also keep track of all parts used in the repair. This information is used to update the shop's inventory and to ensure that the customer is billed correctly for the parts used. Many shops use a computerized inventory management system to track parts usage. Accurate parts tracking is essential for inventory management. It also ensures accurate billing. It helps to prevent parts shortages. Once the repairs are completed, the technician should document the work performed on the repair order. This documentation should include a description of the repairs performed, any parts that were replaced, and any other relevant information, such as the results of any tests performed. This documentation serves as a permanent record of the work performed on the vehicle. It can be useful for future reference if the vehicle returns for service. Thorough documentation is crucial for maintaining a complete service history. It can also help with future diagnosis. It is a sign of professionalism. After the repairs are completed and documented, the repair order is typically closed out and an invoice is generated for the customer. The invoice should include a detailed breakdown of all charges, including parts, labor, and any applicable taxes or fees. The invoice should be reviewed carefully to ensure that it is accurate before it is presented to the customer. Accurate invoicing is essential for customer satisfaction. It also ensures that the shop is properly compensated for the work performed. It is a crucial part of the business. In addition to repair orders, other types of documentation are also important in the automotive repair industry. These can include inspection reports, diagnostic trouble code, DTC, printouts, and technical service bulletins, TSBs. Maintaining accurate and organized records is essential for providing quality service and ensuring customer satisfaction. Proper documentation can also protect the shop from liability in case of disputes. It provides a record of the work performed. It is an important aspect of running a successful business. Furthermore, documentation plays a crucial role in maintaining a vehicle's service history. A well-documented service history can increase the resale value of a vehicle and provide valuable information to future technicians who may work on the vehicle. It provides a record of all maintenance and repairs performed. It can help to identify recurring problems. It is a valuable asset for any vehicle owner. In conclusion, while this lesson provides only a brief overview, it's clear that documentation and repair orders are integral components of the automotive repair process. They serve as a means of communication, a record of work performed, and a tool for tracking costs and inventory. While technicians primarily focus on the hands-on aspects of repair, their contribution to accurate and thorough documentation is crucial for the smooth operation of the shop and the satisfaction of customers. The principles discussed in this lesson, although covered briefly, will be reinforced through practical application and further learning throughout the course. Proper documentation is a skill that every technician must develop. It is a vital part of the job. It is essential for success in the field. Lesson 20, Setting a Solid Foundation, Summary of Essential Safety, Tools, and Procedures as a Base for Future Courses. This foundational course, Automotive Fundamentals and Shop Safety, has laid the groundwork for a successful and safe career in the automotive repair industry. Throughout the previous 19 lessons, we have explored a wide range of essential topics, from basic shop organization and tool familiarization to the intricacies of electrical circuits and the importance of accurate documentation. This concluding lesson serves as a comprehensive review of the core concepts covered, emphasizing the interconnectedness of safety, tools, and procedures as the bedrock upon which all future learning will be built. Mastering these fundamentals is not just about passing a course, it's about developing the mindset and skill set necessary to become a competent, responsible, and ultimately, successful automotive technician. This foundation is crucial for future learning. It will be built upon in subsequent courses. It is the key to success. Safety has been a recurring theme throughout this course, and for good reason. The automotive repair environment presents numerous potential hazards, from heavy machinery and electricity to hazardous chemicals and sharp tools. A steadfast commitment to safety is not just a matter of following rules, it's about cultivating a proactive mindset that prioritizes the well-being of oneself and one's colleagues. Personal protective equipment, PPE, such as safety glasses, gloves, and hearing protection, should always be used when appropriate. Proper lifting techniques should be employed to prevent back injuries. Work areas should be kept clean and organized to minimize the risk of trips and falls. Safety is not just a set of rules. It is a way of thinking. It is a habit. Understanding and adhering to safety regulations, such as those established by OSHA, is also crucial. These regulations are in place to protect workers from harm and to ensure a safe working environment. Familiarizing oneself with these regulations and consistently following them is not just a matter of legal compliance, it's a fundamental responsibility of every automotive technician. Safety regulations are there for a reason. They should be followed at all times. They are designed to protect workers. Proper handling and disposal of hazardous materials are another critical aspect of safety in the automotive repair environment. Chemicals, such as solvents, cleaners, and lubricants, should be handled with care, and appropriate PPE should be worn. Safety data sheets, SDSs, should be consulted for information on the hazards associated with each chemical and the proper handling procedures. Used fluids, such as engine oil, coolant, and brake fluid, should be disposed of properly in accordance with environmental regulations. Proper handling and disposal protect both people and the environment. It is a responsibility that should be taken seriously. It is crucial for a safe shop. This course has also emphasized the importance of proper tool usage and maintenance. Using the correct tool for the job is essential for preventing damage to components, ensuring accurate repairs, and minimizing the risk of injury. Tools should be regularly inspected for damage or wear and replaced when necessary. Proper storage and handling can help to extend the life of tools and maintain their accuracy. Knowing how to use tools correctly is just as important as having the right tools. Proper tool usage is a sign of a skilled technician. It is essential for quality work. Calibration of tools and equipment, such as torque wrenches, air gauges, and alignment racks, has been highlighted as a critical aspect of ensuring accurate measurements and reliable repairs. Regular calibration, performed according to manufacturer recommendations, is essential for maintaining the accuracy of these instruments. Calibration should be performed regularly. It ensures that tools are providing accurate readings. It is a crucial part of quality control. The course has also provided an introduction to the major automotive systems, including the engine, transmission, electrical system, brakes, steering, and suspension. While these systems will be explored in greater depth in subsequent courses, understanding their basic function and how they interact with each other is essential for any aspiring technician. This foundational knowledge will be built upon in future courses. It provides a framework for understanding how vehicles operate. It is essential for diagnosis and repair. The importance of accurate and thorough documentation has been another recurring theme. Repair orders, inspection reports, and other forms of documentation are essential for maintaining accurate vehicle service histories, tracking repairs, and communicating effectively with customers and colleagues. While this course provided only a brief overview of documentation, it emphasized the importance of clear, concise, and accurate record keeping. Proper documentation is essential for a well-run shop. It is also important for customer satisfaction. It is a vital part of the business. Throughout this course, the interconnectedness of safety, tools, and procedures has been emphasized. Safe work practices are essential for preventing accidents and injuries. Proper tool usage and maintenance ensure accurate repairs and extend the life of equipment. Following established procedures, such as those outlined in service manuals and technical service bulletins, ensures that repairs are performed correctly and efficiently. These three elements are intertwined. They are all essential for success in the field. They are the foundation of quality workmanship. As you move forward in your automotive education, the principles and concepts covered in this foundational course will serve as a constant guide. Each subsequent course will build upon this foundation, delving deeper into specific systems and diagnostic techniques. However, the importance of safety, proper tool usage, and adherence to procedures will remain constant. These principles are universal. They apply to all aspects of automotive repair. They are the mark of a true professional. Remember that continuous learning is essential in the ever-evolving automotive industry. New technologies and systems are constantly being introduced, requiring technicians to stay up to date with the latest advancements. Attending training courses, reading industry publications, and participating in online forums are just a few ways to stay informed and maintain a competitive edge. Lifelong learning is crucial for success. It allows technicians to adapt to new technologies. It is a sign of a dedicated professional. The automotive repair industry offers a rewarding and challenging career path for those who are passionate about vehicles and dedicated to providing quality service. By mastering the fundamentals covered in this course and committing to continuous learning and professional development, you will be well equipped to succeed in this dynamic field. The skills and knowledge you have gained will serve as a solid foundation for your future endeavors. This course is just the beginning. It is the first step on a long and rewarding journey. In conclusion, this course, Automotive Fundamentals and Shop Safety, has provided a comprehensive introduction to the essential knowledge and skills required for a successful career in automotive repair. By emphasizing the importance of safety, proper tool usage, adherence to procedures, and accurate documentation, this course has laid the groundwork for future learning and professional growth. As you continue your journey in the automotive field, remember the principles and concepts covered in these lessons, and strive for continuous improvement in all aspects of your work. This foundation will serve you well. It will guide you throughout your career. It is the key to success in the automotive industry. This course has provided the building blocks. Conclusion: this foundational course, Automotive Fundamentals and Shop Safety, has provided a comprehensive introduction to the core principles and practices that underpin a successful and safe career in the automotive repair industry. Throughout the 20 lessons encompassed within this course, we have journeyed from the basics of shop organization and tool familiarization to the complexities of electrical circuits, the intricacies of modern diagnostic techniques, and the vital importance of meticulous documentation. This concluding chapter serves not as a finale, but rather as a bridge, connecting the fundamental concepts learned here to the more advanced topics that await in future courses. The knowledge and skills acquired in these lessons are not merely academic exercises, they are the bedrock upon which a competent, responsible, and ultimately, successful automotive technician is built. This course has laid the groundwork for your future success. It has provided you with the essential tools and knowledge. It is now up to you to build upon this foundation. A recurring theme throughout this course has been the paramount importance of safety. The automotive repair environment, with its inherent hazards, demands a constant awareness of potential dangers and a proactive approach to accident prevention. We have explored the proper use of personal protective equipment, PPE, emphasizing that safety glasses, gloves, and hearing protection are not optional accessories but essential safeguards. We have examined safe lifting techniques, stressing the critical role of proper vehicle lifting and jacking procedures in preventing catastrophic accidents. Furthermore, we delved into the safe handling and disposal of hazardous materials, highlighting the importance of adhering to environmental regulations and protecting both personal and environmental well-being. Safety is not just a set of rules to follow. It is a mindset that must be cultivated. Hand in hand with safety is the proper use and maintenance of tools. This course has introduced a wide array of tools, from basic hand tools like wrenches and screwdrivers to sophisticated diagnostic equipment like scan tools and alignment racks. We have emphasized the importance of selecting the correct tool for the job, using it properly, and maintaining it in good working order. The principles of tool calibration have been explored, highlighting the need for periodic verification and adjustment to ensure accuracy. Proper tool usage and maintenance are not just about efficiency. They are about ensuring the quality of repairs. Beyond the physical tools, we have also explored the informational tools that are essential for modern automotive repair. Service manuals, both printed and online, have been presented as invaluable resources, providing detailed specifications, procedures, and diagrams. The ability to navigate these manuals, interpret technical information, and apply it to real-world repair scenarios is a skill that will be continuously honed throughout your career. Online databases and technical service bulletins, TSBs, have also been introduced as valuable sources of information, providing access to a wealth of knowledge and updates. Knowing where to find the right information is crucial. It is just as important as knowing how to use it. The course has also provided a foundational understanding of major automotive systems, including the engine, transmission, electrical system, brakes, steering, and suspension. While these systems will be examined in greater detail in subsequent courses, the introductory overview provided here has established a framework for understanding their basic functions and interrelationships. This foundational knowledge will be essential for diagnosing and repairing problems in these systems. It will be expanded upon in future courses. It is a starting point. Documentation, though briefly covered, was presented as a critical aspect of the automotive repair process. Repair orders, inspection reports, and accurate record-keeping are not mere administrative tasks, they are essential for maintaining vehicle service histories, ensuring clear communication, and protecting both the shop and the customer. Proper documentation is a sign of professionalism. It is essential for a well-run business. It is a vital part of the job. Workplace etiquette and professional communication were also addressed, emphasizing the importance of respectful interactions with colleagues and the value of teamwork in a demanding environment. While customer interaction was only touched upon, the principles of clear communication, active listening, and maintaining a professional demeanor were highlighted as essential for building positive relationships with both colleagues and customers. These skills are often overlooked. They are just as important as technical skills. They contribute to a positive work environment. As you progress to more advanced courses, the principles and concepts introduced in this foundational course will serve as a constant reference point. The emphasis on safety, proper tool usage, adherence to procedures, and accurate documentation will remain relevant regardless of the specific system or repair being addressed. Remember that continuous learning is essential in this rapidly evolving field. Embrace new technologies, stay updated with industry advancements, and always strive to improve your skills and knowledge. This course has provided you with a strong foundation. It is up to you to build upon it. In conclusion, Automotive Fundamentals and Shop Safety has equipped you with the fundamental knowledge and skills necessary to embark on a successful career in the automotive repair industry. By embracing the principles of safety, mastering the use of tools and equipment, understanding the importance of accurate information, and committing to continuous learning, you are well prepared to tackle the challenges and reap the rewards of this dynamic and essential profession. This course is just the beginning of your journey. The knowledge you have gained here will serve you well throughout your career. Congratulations on completing this foundational course, and best of luck in your future endeavors.